Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
Hey guys, welcome to codingbootcamps.com. Be sure to follow us on social media on platforms such as Facebook, LinkedIn, and YouTube. Today, we're going to be talking about one of our courses, which is Introduction to Linux System Administration. I'll be the instructor for the course. I'm a Red Hat certified system administrator, and at my current job, I'm in charge of administering hundreds of servers running on different Linux distributions. I work as a Unix system administrator supporting several large enterprise-level clients with IBM across multiple different environments. As an RHCSA, I'm adept at Linux programming for both managing personal and server Linux systems. I'm also pursuing my Red Hat certified system engineer as well as DevOps. So let's talk about this course a little bit. So the prerequisite for this class is you need to do Introduction to Linux OS. If you haven't taken that course yet, be sure to follow this link and take that course before you do this one. Without that class, you're going to be playing a lot of catch-up to try and learn some of these commands and some of the concepts we're talking about. So make sure you do this class first, okay? Some of the topics that are going to be covered in this course, and this is just a high-level list of topics covered in the class, is System Administration Overview, Installation and Configuration, Booting and shutting down Linux, managing software and devices, managing users and groups, the Linux file system, Linux file security, and controlling processes. There's going to be homework with 3 parts of it for managing users, groups, permissions, access, control lists, and more. So you get a little hands-on learning there along with the actual lectures that you can follow at your own pace. So the takeaway you're going to be taking from this class is a high level of review of how you can actually be a sysadmin, okay? So with these skills, you can actually take on jobs such as a developer, consultant, and even a sysadmin role with the knowledge that you gain from these courses, okay? Some follow-up classes you can take after this course is going to be learning PHP programming, Intro to Linux Bash scripting, which will be another course that I'll be teaching, how to manage Red Hat or CentOS Linux servers, intermediate level, okay, so that'll be the intermediate version. I'll also be teaching that course. And then Intro to HTML and CSS, okay? So be sure, go to codingbootcamps.com, check out all the courses, make sure you take this course, and then follow up with some of those other courses that we listed there, okay? Thank you so much, guys, and I hope to see you on this first session of the course. Hey guys, welcome to our second course, Introduction to Linux System Administration. My name is Kevin Nouns. I'm hoping some of you followed me over here from our first course, Intro to Linux OS. If not, a little bit about myself. I'm a Red Hat Certified System Administrator, or RHCSA. At my current job, I'm in charge of administering hundreds of servers running on different Linux distributions, and I work as a Unix System Administrator supporting several large enterprise-level clients with IBM across multiple environments. Now, I'm pretty good at understanding Linux programming so that I can manage both personal and server Linux systems. And I'm currently pursuing my RHCE, or Red Hat Certified System Engineer, and DevOps. So if you are taking this course, guys, it is highly recommended that you take our course, Introduction to Linux OS. If you haven't taken that yet, please click on the link and follow it to that course. In that course, we're going to be talking about a lot of the things that we're just going to be taking as assumed knowledge for this course. So please take that course before you take this one. Alright, so this first session is going to be Linux System Administration. And it's going to be an overview of the sysadmin role. In it, we're going to go over Unix, Linux, and open source, duties of the sysadmin, superuser and the root login, sharing superuser privileges with others via su and sudo commands. We're also going to go over TCP/IP networking fundamentals. So let's go and talk about Unix. The Unix brand has traditionally been applied to the family of multitasking, multi-user computer operating systems that derive from the original AT&T Unix operating system. It was developed in the 1970s at the Bell Labs Research Center by Ken Thompson, Dennis Ritchie, and others. Linux, on the other hand, is a name which broadly denotes a family of free and open source software operating system distributions built around the Linux kernel. And guys, Linux is what's going to be much more commonly used these days. You're not going to see too often any more systems running on Unix. Now most things are going to be run on Linux. So open source software is computer software with its source code made available with a license in which the copyright holder provides the rights to study, change, and distribute the software to anyone and for any purpose. So guys, this is different from Microsoft. Microsoft, in order to use Windows or any of their Microsoft servers, you actually have to pay to get a license from them to use it, okay? Linux is open source here, meaning you can just grab it, download it, and start using it, okay? That doesn't mean there aren't any Linux systems out there that are paid to use. For example, Red Hat is a paid subscription to use. It's actually pretty commonly paid for. That's because it has a ton of support for it from the Red Hat company itself. So the duties of the sysadmin include, but are not limited to, user administration, such as setup and maintaining accounts and creating users, maintaining the system, verify the peripherals are working correctly. And peripherals can be printers, CD-ROM, tape drives, etc. Quickly arrange repair for hardware in occasion of hardware failure, monitor system performance, create file systems, install software, create a backup and recovery policy, monitor network communication, and update systems as soon as a new version of OS application software comes out through patching. We also do implement the policies for the use of the computer system and network. We set up security policies for users. A sysadmin must have a strong grasp of computer security, for example, firewalls and intrusion detection systems. And documentation in form of an internal wiki is very important as a sysadmin. You want to be able to reproduce things that you do and hand it off to your other workers. And then password and identity management. Let's talk about super users and the root login. So in computing, the super user is a special user account used for system administration. Depending on the operating system, or OS, the actual name of this account might be root, administrator, admin, or supervisor. In some cases, the actual name of the account is not the determining factor. On Unix-like systems, for example, the user with a user identifier, UID, of 0 is the super user, regardless of the name of that account. And in systems which implement a role-based security model, any user with the role of superuser, or its synonyms, can carry out all actions of the superuser account. And this is typically how it's done, guys, is this role-based security model. So the principle of least privilege recommends that most users and applications run under an ordinary account to perform their work, as a superuser account is capable of making unrestricted, potentially adverse system-wide ranges. As a sysadmin, guys, you're going to be given superuser privileges by default and root access. So people you're typically working with won't have root access, and they're going to be asking you to do a lot of things since you do have root access and sudo access. And as a sysadmin, you'll give certain accounts or clients privileges, so you can set up certain commands that they can do or certain privileges so that they can perform the things they need to do, but nothing else, just simply the things that they run on a daily basis. So let's look at sharing superuser privileges with others. SU forces you to share your root password to other users, whereas sudo makes it possible to execute the system commands without root password. Okay. Sudo lets you use your own password to execute system commands, i.e. delegate system responsibility without root password. Okay. So you see the first example here, sudo, and then we type in a command. It's going to ask us for our password. You'll type it in, and then it lets us run that command as the super user. Okay. SU, okay, or which can also be looked at as a switch user, will have you type in a command or type in your password, and then actually switches you up to that super user. Okay. So if you don't want to have to type in sudo before every command, then you can just do an SU and it'll switch you up to super user for the rest of that session, and then you can just start typing in commands. So it's a little bit quicker and easier to do this way. Let's take a look at the TCP/IP networking model. So the Transmission Control Protocol and Internet Protocol, or TCP/IP, suite was created by the U.S. Department of Defense to ensure that communications could survive any conditions and that data integrity wouldn't be compromised under malicious attacks. So TCP/IP has the below parts. We have the application layer. The application layer deals with representation, encoding, and dialog control issues. All these issues are combined together and form a single layer in that TCP/IP model. Host to host, Host-to-host protocol in the TCP/IP model is responsible for application data segmentation, transmission reliability, flow, and error control. The internet layer. The purpose of the internet layer in TCP/IP model is to route packets to their destination independent of the path taken. And then we have our network access layer. The network access layer deals with all physical issues concerning data termination on network media. It includes all the concepts of data link and physical layers for both LAN and WAN media. Okay, and LAN stands for local area network, and WAN stands for wide area network. So here we have a little bit of a picture to kind of summarize everything we just talked about. So a little bit of a visual representation. So here we have our application layer. Next to that, we show all the different protocols underneath that layer. Then we have host-to-host, all the protocols under that. Internet layer, and we show all the protocols under that. And then we have our network access layer, and it's going to show all the protocols under that. Okay. Guys, I highly recommend following this link here to get a little bit more grasp of the TCP/IP protocol. As a sysadmin, you're not going to be super focused on networking concepts. You don't have to be an expert at networking, but you do need to know about it. It helps you understand how things are working and what's going on, and it'll help your job be a little bit easier. So looking forward, guys, in our next session, we're going to learn about planning, hardware and software considerations, site planning, installation methods and types, installation classes, partitions, logical volume manager or LVM, file system overview, swap partition considerations, other partition considerations, the Linux bootloader or grub, and software package selection. So guys, there's going to be a lot of concepts we cover in these courses. I recommend that you follow these links if you're having issues or troubles. There are going to be private tutoring sessions for system administrator management. There are weekly, monthly plans available. And we also have Linux and Bash scripting private tutoring sessions available. Thank you so much for following this first session with you guys. I hope that we really learn a lot from this course moving forward, and that you guys don't have too much of a difficult time understanding what's going on. Looking forward to seeing you guys in the next session. Hey guys, welcome to session 2 of Introduction to Linux System Administration. My name is Kevin Downs, and I'm going to be your instructor for this course. Today we're going to go over installation and configuration. In our last session, we went over Unix, Linux, and open sources, duties of the sysadmin, superuser and the root login, sharing superuser privileges with others via su and sudo commands, TCP and IP networking fundamentals. Today, we're going to go over planning, hardware and software considerations, site planning and installation methods and types, installation classes, partitions and logical volume manager LVM, file system overview, swap partition considerations and other partition considerations, the Linux bootloader or grub, software package selection, editing and configuring peripherals, printers and graphic controllers, basic networking configuration, and booting to recovery mode. So let's look at planning, hardware, and software considerations. Linux supports a wide range of PC hardware, but not even Linux supports every known device and system. Your PC must meet certain requirements in order to run Linux. So let's look at the CPU. Linux does not support the Intel 286 and earlier processors. However, it fully supports the Intel 8386, 8486, Pentium, Pentium Pro, Pentium 2, and Pentium 3 processors. Nevertheless, some users feel that their 803086 Linux system responds sluggishly, particularly running X. So, if you want optimal performance, you should install Linux on a PC having at least an 8486 processor or better. Linux does also support non-Intel processors such as the Cyrix 6x86 and the AMD K5 and K6. Most Linux users have systems that use Intel chips. If your system uses a non-Intel chip, however, you may find it more difficult to resolve possible problems. So looking at the motherboard, Linux supports the standard ISA, EISA, PCI, and VSA or VLB system buses used on most IBM-compatible PCs. Linux recently gained support for IBM's MCA bus used in IBM's PS2 series of computers. However, at the time of this writing, Debian GNU Linux does not yet support the MCA bus. So if you have an IBM PS2 bus, you may be unable to install the Debian GNU Linux, but you're going to have to check the Debian project website for the latest available information on whether or not it supports that. Your motherboard should include at least 16 megabytes of RAM. okay, for optimum Linux performance. Some users have managed to coax their Linux into working on systems with as little as 4 megabytes of RAM. However, if your system has less than 16 megabytes of RAM, you
Thanks for watching. Feel free to add your questions as comments down below.
probably won't be pleased with its performance. If you plan to run X, you may wish to install more than 16 megabytes of RAM, perhaps maybe 64 megabytes. Although X operates well with the 16 megabytes of RAM, you can open more windows and switch between them more quickly if you have additional memory. Let's look at the disk storage. So Linux is actually not too hungry for disk space. To install and use Linux, you really only need about 250 megabytes of free hard disk space, the minimum being 100 megabytes. But installing Linux on a system with so little disk space, it's going to compel you to emit too many useful applications and will leave you with little room to work. And honestly, the minimum requirement should actually be about 10 gigs. You're going to want to install about 10 gigs on there in case you want to store files and videos and other things like that. So you could probably get away with as little as 10 gigs total for everything that you need. So, site planning. With any IT system, it is desirable that the system and its components, be they hardware or software, up and running, fully functional for as long as possible, to their highest availability. So the most desirable high availability rate is known as the 5 nines, okay, or 99.99% available. So this will help you deal with a significant outage with the data center on the following factors: LPAR failure, operating system outage, and application event. And guys, I deal with this a lot in my sysadmin role. We have a lot of jobs that have been or stopped running for unknown reasons. We have to figure out why and get them back up and running as quickly as possible. So here's a little graph as far as availability goes. Guys, don't worry about this too much. This is just an example of like kind of how things are planned and what it will look like to plan the systems and set up an actual data center. As a sysadmin, you're really not going to be putting site plans like this. Maybe once you start getting to architect or engineer levels, you'll have to set up something like this. But this is just showing the planning that goes into getting a data center or a server room set up. Okay, so you got to look at your LPAR and different ways to connect via WAN and LAN, and you can have all your database servers and your internet and your intranet. So I will point this out. Internet is going to be internet to the outside world. Intranet is going to be internet to within your own system, meaning you're connecting within your own system. So this is how everything connects inside your different servers with each other. Okay. All right, let's go ahead and talk about installation methods and types. So below you're going to see some following various methods to use when installing the Linux machine that you're going to be installing. So the first one we have is DVD and CD-ROM. Typically this isn't going to be used anymore. Instead we're going to use the following four more frequently. We have hard drive, we have NFS, which is network file share system, and then FTP, which is file transport protocol, and then HTTP, which is hypertext, which is going to be internet. And that's basically how we're going to install our image. Is we're going to go to the CentOS org website and download the .iso file and install it from there. There's going to be two classes you can use. We can do the CentOS 7 GUI or the CentOS CLI. So with the GUI or graphical user interface, we're going to get this nice beautiful desktop. Or with the CLI, we can use that option as well. And that's awesome, guys, because that's actually where sysadmin lives and breathes. That's where we're going to do most of our work as a sysadmin. And you actually have a lot more control over this system. So let's go ahead and check out where to get this image from. Got our web browser here. So you're going to go to centos.org/download/. Once we're on here, we're going to go ahead and click on 8 because that's the most recent version available. We're going to go under ISO. We're going to click on this 8664 one. It's going to take us to this page. We'll click on the first one available. And you'll see a couple of ones here. Okay, we're going to click on this largest one here, the one that says DVD.iso. Your screen might be a little bit different when you click on it, and this may be shortened up and this may be in gigs. So just pick the largest one you see, which should be this DVD.iso one. Okay, we'll click on that. It'll download. It'll take some time depending on your download speed. Could take 10 minutes, could take an hour. Just give it time to download. Once we have that, we'll go ahead and go to our virtual box. We'll click New, and then it'll bring up the next screen. And we're going to type in CentOS, and you'll see it'll recognize that as a Red Hat product. We'll go ahead and leave it as Red Hat 64-bit here. We'll click Next. And again, I like to double the RAM. It tells you 8 gigs is going to be probably the recommended size of the hard disk. We'll probably do 10 gigs. We'll click create a virtual hard disk now. We'll do create. Bring up that next screen for you. There we go. Let me move that up so you can see the whole thing. A little bit less. There we go. Alright. And on the screen, we're going to stick with VDI. We'll click next. So like I said, minimum is going to be 8 gigs. We'll go ahead and give it 10 gigs. That should be plenty. And from there, it's going to take us back to the original screen. We're going to double click because it's going to ask us what image we want to boot from. So you see here, it has that original Ubuntu image. What you're going to need to do is you're going to need to click on that and you're going to search for where you stored your .iso image for CentOS. Mine happens to be on my desktop, so I'll go to my desktop and grab it from there. And I'll choose that one. And now we see we have the CentOS ISO image. So we'll click Start. We'll bring up this screen. Make sure that when you do this, guys, that you do the install option. So it's kind of tricky. It's not very obvious which option you're clicking. So I would go all the way down and then press all the way up to make sure you're on the Install CentOS Linux 8 option. So we'll hit Enter. We'll start booting up that machine. Now you'll notice your mouse kind of disappears on this one. Ubuntu, your mouse could flow in and out of VirtualBox, no problem. On CentOS, it actually captures your mouse inside of this VirtualBox. So to get out of that, you have to click right on your D-pad and then Control button. And now your mouse will be free to go back to your actual laptop or computer or desktop. So we'll go ahead and let that installer load up. Won't take too long. Alright, so once it's up, you go ahead and start selecting the options that you would like. And make the screen a little bit smaller so you guys can see the whole thing. A little bit less. A little bit less. Oops. Sorry, bear with me, guys. There we go. Now you should be able to see the whole thing. Okay. So I'm going to stick with English for my format. Pick whatever language you would like to do. We'll click Next or Continue. So from here we have keyboard English, language support English, time and date. We're going to click on that. You're going to select the time zone you're in. I'm in the Midwest. I'm going to go ahead and stick with Central Standard Time. We'll click Done in the top left here. And you can change this to 24-hour format or AM, PM format. You can change the date if you need to, but it should select all that for you. We'll click Done. We'll do installation source. We're not going to mess with anything on here. We'll just click Done. Soft selection. So this is where you can pick the different classes. So we talked about doing it with GUI or just minimal install, which is the command line interface. We'll go ahead and do the GUI. You'll notice some options on the side here you can pick as well. We're just going to do server with GUI, okay? So we'll click Done. And over here you see exclamation point. It's telling you automatic partition selected. We'll click on that. So this is where you can actually set up the partitions if you want. You can do custom, you can add your boot, swap, and others. I don't recommend doing that, guys. I recommend just letting it automatically do that for you, so it will be set up. You don't have to worry about it. But if you'd like to do it on yourself and actually set up the boot and the swap and all that, there are tutorials online that you can follow to do that. So we'll just leave it automatic here. We'll see KDump is enabled. We're going to actually disable that because it makes the installation process longer and we don't need it, so we'll disable it. We'll click on Network in Host Manager. We're just going to click this little button here to enable our network. So it's on now, and we'll click Done, top left here. And then the security policy, we don't need to worry about that. Nothing there that we need. So we'll go ahead and click Begin Installation. While this is installing, we can go ahead and set up our root account. So we'll click on Root. We'll set our root password. I'm going to type in my password. You'll see there it says that it's strong password. So don't even try to guess it, guys. There's no way you're going to guess it. It's too strong of a password. No, I'm just kidding. You wouldn't be able to connect to my machine anyways unless our machines were connected on the same network. And then we can create our user. So I'm going to type in my full name. So this is similar to Ubuntu, where we type in our name, it creates a username for us. If you want to create a custom username, you can just click in this box, change it to wherever you like. We're going to go ahead and keep the option selected that says require a password to this user account. So we're going to type in a password again. Perfect. Tells us we have a strong, secure password. You can see that bar here, strong password. We'll click Done. And then we just have to wait for it to install. Okay. So right now, guys, I would encourage you to go ahead and fast forward the video. This part's going to take a little time. Since we disabled KDump, it's going to go by a little bit faster, but it is still going to take some time since we picked that GUI option. If you pick the minimal option, this should go by pretty quick, actually. Okay. And if you forgot to disable KDump, this is actually going to take a little bit longer. Okay. So make sure you did disable KDump on that installation. If you want to stick around and keep me company while I wait for this install, you're more than welcome to. However, I'd recommend just go ahead and fast forwarding the video until the end of the installation here.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Alright guys, hopefully you've been fast forwarding through this, but we should be getting close to the completion of this installation. Alright guys, so hopefully you fast forwarded to this part of the video so you didn't have to sit through all that, but we are ready now to reboot our system. Now when we click reboot, you're going to notice something happens. Give it a second here, but what's going to happen is it's actually going to ask you to install again. You're going to be a little confused here. You're going to be like, didn't I just install it? Don't fall into the trap of pressing install. What we're actually going to do is we're going to exit out of this. So we can go to File, Close, and power off the machine. We'll click OK. And we're going to go back to our virtual machine, our home. Okay. What I need you to do is go ahead and click on your CentOS machine. Oops. We're going to click on, so we'll click on CentOS, then we're going to click on Settings. Okay. Let me pull up that screen for you. There we go. Let me make this smaller so you can actually see it. There we go. Alright, and on the settings screen here, what we're going to do, we're going to go to System. Okay. And then here on System, what we're going to do is we're going to uncheck floppy. Okay. We're going to click on optical, and then we're going to go to this little arrow here. We're going to click that up. We're going to click on hard disk. We're going to click the up arrow. And now what we have is we have the optical and hard disk are going to boot in this order. So first it'll try to boot from optical, and then it'll try to boot from the hard disk. So what was happening is it was trying to boot from a floppy that didn't exist, okay, and so that's why I didn't see the installation. So now it should be booting in the correct order. So we'll go ahead and click OK in that bottom right corner that you can see down there. Okay. And I'll save the settings. Now we're back at our home screen here. A little bigger. There we go. And we'll double click on CentOS. Oh, actually, 1 second here. Looks like it's still trying to. Alright, give me 1 second, guys. Looks like it's still trying to boot from. Let's close that. Okay. Let's go to settings again. System. Okay, maybe. Now let's try it. There we go. Okay, now it's working. Let me show you guys the right screen here. Okay. So actually, while that's coming up, we put it in the wrong order. So on settings, you actually need to go to, you need to put the hard disk first. And then optical image second, okay? And then it'll boot from the correct image. So now we got it loading up here. I'll show you that after it both loads up here. Perfect. So the last thing we gotta do here is we gotta click on the license. We need to accept it. So you can read the license. We'll go to this little box here, click select, say okay, I accept the license agreement, then we'll click done. And we'll click finish configuration. And there you go. We have a functioning VM now. So we can click on that, log in our user. Now if you want to log into root on your machine, you would go to not listed.
Thanks for watching. Please like and share this video.
Type in root. And then you would type in the root user password. And now you're logged in as root. Okay. Now guys, I don't really recommend doing this for right now. Once later on down the road you get used to sudo and all that and understand all the commands and privileges, you can do that. But for now, go ahead and log in as a regular user. It's going to take you through some things when we do log in. So we'll do English. Pick whatever language you prefer. We're going to turn off the location services. And we're ready to go. Okay. We'll pull up some tutorial videos for you. So it's very similar to Ubuntu. We have our start menu here, top left activities, and it'll pull up a very similar menu bar. We can search for things that we're looking for, such as some of those programs that we used before, calculator, LibreOffice calculator, things like that. Okay. Let me go ahead and turn this machine off. So we go to File, Close, Power off the machine. I'm going to show you what we should have done in the settings to make it boot correctly. So we should have gone to Settings, pull up the settings screen for you. 1 second. Alright, there you go. We should have gone to Settings, System, and we had it in this order. We had optical disk and then hard disk. It should be hard disk first and then optical disk under Settings and then System here. Okay, that's how it should be set up: hard disk and then optical, and then everything else unchecked. Okay, so that's how it should be set up. Alright, so you guys should have your lab set up now, and we'll be able to actually demo some things on CentOS. Alright guys, we're going to spend a decent amount of time going over partitions on the Linux file system. So each distribution's installation guide contains, or at least it should contain, a section on partitioning your hard drive. Personally, I favor the KISS principle, or KISS principle, which just stands for keep it simple, stupid. Okay, so this is especially for beginners. Alright, so we just want to try and keep our partitions as simple as possible. Don't need to get fancy with it. We saw on our server, or our VirtualBox, we even just let it do it automatically. Okay, so that's going to be the easiest way to do it. So if you are installing a server that will serve multiple users simultaneously and provide a myriad of services, you will want to read the manual sections as well as the partition mini how-to. This is an excellent document detailing the reasons one might want to create the 7 or more partitions. Okay, so that's a good document to read to actually see how to install each partition on your hard drive. In our case, on VirtualBox, it went ahead and did it for us. So how different partitions and storage is managed on Linux servers is through LVM, which stands for Logical Volume Manager. Okay, this is a tool for logical volume management, which includes allocating disks, striping, mirroring, and resizing logical volumes. So striping and mirroring is a way that data can be stored. So with mirroring, you're just going to store the same data on another disk. And striping means you're going to take one strip on a hard disk and you're going to store that same strip on another hard disk. What this is doing is creating redundancy and backup. In case one disk gets corrupted, you still have the info on the other disk. So with LVM, a hard drive or a set of hard drives is allocated to one or more physical volumes. LVM physical volumes can be placed on other block devices which might span 2 or more disks. The physical volumes are combined into volume groups, which can then be turned into logical volumes. I'm going to go ahead and highlight these as well too, guys, because this is really the main parts. Oops. It's really the main parts of LVM. Oops. Don't want all of that. Okay. So we've got our physical volumes, volume groups, and our logical volumes. So the physical volumes are combined into volume groups, which can then be turned into logical volumes. With the exception of the /boot partition, the /boot partition cannot be turned into a logical volume group because the bootloader cannot read it, okay? So that's the only partition that cannot be turned into a volume group or logical volume. If the root partition, which is // is on a logical volume, you can create a separate boot partition which is not part of a volume group, okay? Since the physical volume cannot span over multiple drives, to span over more than one drive, create one or more physical volumes per drive. So let's take a little look here visually at what this kind of looks like. So we can have a lot of disks with all having different physical volumes on it. What we can do is we can throw all these different physical volumes into a volume group, and from here we can start shaving off logical volumes from it, okay? So this is nice because we can have a ton of different disks. We can throw whatever storage they all have on them separately into one place, which looks like one disk, and from there we can create logical volumes that can be used for file systems. Okay? So let's take a look at the file system overview. So, have you ever gone looking for a book in a library? In order to find what you're looking for, you must understand the library's file system or method of organization. Okay, so this is a good analogy for how the file system works on Linux, kind of compared to a library. So, fiction books are easy. They use a simple type of file system commonly known as the alphabetical order, right? We sort it by alphabetical order. Non-fiction books can be tougher because they're a different type of file system, the Dewey Decimal System. Now the problem is what if you don't understand the Dewey Decimal System? What if you only know the title of a book and you don't know whether it's fiction or nonfiction? How would you be able to find that book? Luckily there's a librarian to help us, and she has created a card catalog, or in most libraries now a computerized catalog, listing all the books available and where to find them. Okay. So now let's look at our hard drives as books in a library. So like the library, your hard drive can have different file systems. Okay. The operating system is going to be your librarian, who's provided the directory tree, also referred to as the file system with a slightly different meaning, as a catalog of the files available. Okay. So another partition you're going to need on your system is something called swap. Okay. This is space on your hard drive that can be used as virtual memory. So it's very similar to RAM, which stands for random access memory. Virtual memory allows your computer to run large programs or perform complex tasks even if it does not have enough physical RAM to do the job. So when RAM runs out, your system goes to this swap. Okay? It's a lot slower, but it works just the same as RAM. The amount of swap space required is a matter of religious argument among geeks and hackers, and entire volumes can be written about the subject. To keep it simple, remember that KISS principle, keep it simple, stupid. Create one swap partition that has 50% to 100% size of the physical RAM of your system. So you have 2 gigs of RAM, then make 1 gig of swap. 4 gigs of RAM, make 2 gigs of swap, or make it a 1-to-1 ratio. So if you're short on RAM with plenty of drive space, go large. So if you don't have a lot of RAM, but you have tons of storage, you might want to just create a lot of swap space so your system can run a little bit faster. Now keep in mind, this is not as fast as RAM. It's not going to make up for having a lack of RAM, but it will help. Now if you have only a short amount of drive space, but you have lots of RAM, then go ahead and go small on it. You know, do just 50%, maybe less. So next thing we want to look at here is other partitions to consider. First one being root or /. The root file system is represented by a /. It is the top of the directory tree and contains Linux and everything that you will install with Linux. So file systems for, so see the Linux virtual file system for details. So this is roughly equivalent to your C drive on Windows. You know, it's going to be the main drive. And you must create a partition for this directory. Another one is going to be /home. Make sure you're writing these down, guys, because these are important ones to know. So you have /root, /home, which we're going to talk about now. We had /swap. So /home is the third and final partition you should create, which will hold your home directory. Okay. In our last course, we saw that was /home /kdowns. For you, it would have been different depending on your username. So this is the place where all user-specific files, your data in other words, is stored. It is roughly equivalent to the My Documents folder on Microsoft Windows. On a multi-user system, each user will have his or her own directory. So there can be a lot of different home directories on one machine just depending on how many users you actually have on the system. Alright, so we're moving on here to the Linux bootloader, which is called Grub. So GNU Grub, which is short for GNU Grand Unified Bootloader, so GRUB, that's where Grub comes from, is a bootloader package from the GNU project. Grub is the reference implementation of the Free Software Foundation's multi-boot specification, which provides a user the choice to boot one of multiple operating systems install a computer, or select a specific kernel configuration available on a particular operating system's partitions. So, as we're going to talk about here in a few slides, you can use the Grub bootloader to boot into recovery mode. Okay, guys. So all this Grub bootloader means is we can pick which OS and which image to use when we're loading. Okay. So, Grub in CentOS designates disks and partitions as follows. First, all disks are designated as HD, whether they are an IDE, PATA, SATA, or a SCSI disk. SCSI. You'll hear people call that SCSI, guys. Okay? And whether they would usually be designated using HD or SD. Okay? So normally you're going to be designated as HD on the machine, all hard disks. Okay? Second, all disks and partitions are numbered starting with 0 rather than 1. Okay, so 1 is actually 0. And then extended partitions are counted from 4 regardless of what the actual number of primary partitions on the hard disk is. And finally, the first number indicates the disk. The second number, if it's present, indicates the partition. Okay, so let's look at that. So here we have the Grub designation. HD0 is actually going to be the first hard disk. And on the machine, you're going to see it as /dev/SDA or HDA. This means this is the first hard disk on the system. The second hard disk for grub would be HD1, and on the system you would see it as dev SDB or HDB. Okay, so it's just changing that letter from A to B. Okay. Now what happens if we have partitions on it? Okay, well here's an example. We have first hard disk, first partition. On the grub, it's going to be HD0, 0. However, on the machine, when you look it up, it's actually going to be dev SDA1. So first hard disk, A, first partition, 1, or HDA, 1. Okay? And we have more examples here. Second hard drive, first partition, HD1, 0, or SDB1, HDB1. So second disk, B, first partition, 1. And then finally, second hard drive, second partition, HD1, 1, which would be SDB2, HDB2. So, second disk, B, here, second partition, 2. Okay? Let's go ahead and look how we can boot to recovery mode on our systems. Sometimes something goes wrong with our system and we can't get in. It just won't load correctly. Now, this is a huge problem. If you can't load in your machine, you're in trouble, guys. So we have already rooted into the system is a recovery mode, okay? A lot of times the system will just boot into that for you, but sometimes you need to actually get into there manually, okay? So rescue mode is equivalent to a single user mode and requires the root password. Rescue mode allows you to repair your system in situations when it is unable to complete a regular booting process. Rescue mode will try to mount all local files, systems, and start some important system services, but it does not activate network interfaces, neither allow multiple users to be logged in. So there's two ways to get into rescue mode in CentOS. First one is there is a grub2 menu option when you boot up the system, which can be selected to directly boot into rescue mode. Typically, you're not going to have this luxury. So instead, we're going to look at method 2, which is during boot up, when the grub2 menu shows up, press the E key to edit it, okay? You're going to add the following parameter at the end of Linux 16 line. That's going to be this. You're going to add this there. Okay. You'll press Control-A or Home and Control-E to end to jump to the end of the line so that you can add this line there. Okay. Once you're done with that, you'll hit Control-X to boot the system with this parameter. Okay. I'm going to show you part of this now. So I'm going to get my VirtualBox booted up here.
Thanks for watching. Feel free to add your questions as comments down below.
Oh, I missed it. Alright, hold on 1 second, guys. So it is time, so you do have to kind of be quick to the draw there. I missed it because I was trying to pull up the screen. So let me try it again for you. It beat me to it again. Alright, 1 second, guys. Let me actually just go ahead and stop it, and then I'll show you what we need to do. So I'm going to close that. Do that. Alright. Alright, so when that first screen pops up, you're going to hit E to edit. And now you'll see here we're in a kind of a emergency mode. We're going to change some things here. So we go to the line that says Linux. We click our End button. Or I'm sorry, we click Control-E to go to the end of the line. And then we would just type in that info there. I'm going to go ahead and, oops. Control-E, go to the end of the line. Do system d.unit. equals rescue dot target. Okay. Now I'm not actually going to do it, but I would click Control X. This would reboot and would put me into rescue mode. Okay, rescue target. Okay, and then from there I would have to take it back out of rescue mode. Okay. But this is where you do it and how you would do it. I'm going to go ahead and turn the machine off because I want it to boot up normally. So I'm just going to power it off so it doesn't take those into effect. Okay. So that's how you would boot into rescue mode on your machine. Okay. Hopefully in this class you'll never have to do that, but you may make a mistake, and if you do, that's how you're going to get into rescue mode and kind of troubleshoot what you had going on there. Alright guys, we're going to go ahead and start talking about software package selection. So to specify which packages will be installed, select software selection at the installation summary screen. So the package groups are organized into base environments. These environments are predefined sets of packages with a specific purpose. So for example, the virtualization host environment contains a set of software packages needed for running virtual machines on the system. So guys, this is that screen where we saw server GUI, minimal installation, FTP server. So this is that screen, and on there you saw a bunch of different types, and we can click on those and they're all going to have predefined packages installed with it to optimize it for that role. So for each environment there are additional packages available in the form of add-ons. Add-ons are presented in the right part of the screen, and the list of them is refreshed when a new environment is selected. So you can select multiple add-ons for your installation environment. So on that screen, if you remember, we saw on the right hand side there's a bunch of things that we could add to it. Okay. So those are add-ons, additional functions and features we can add. Let's talk about graphic controllers. As Linux becomes more user-friendly and game developers add Linux support, the biggest question, outside of what physical card to buy, seems to be graphical driver and performance. So with varying levels of support for each platform, the performance of a graphics card will vary from OS to OS. Typically, Linux is favored in enterprise-level environments, guys, because they're not very graphically intensive. Okay, you don't need a very good graphics card or processing to handle it. We just need the command line interface. So, Linux isn't great for gaming, although, like we just discussed, it is becoming more popular and it's getting more support for that. So let's talk about the basic networking configuration. Before delving into the interface configuring files, let us first itemize the primary configuration files used in network configuration. Understanding the role these files play in setting up the network stack can be helpful when customizing a Red Hat Enterprise Linux system. The primary network configuration files are as follows. They're going to be stored in /etc/host. That's going to be the first one. And the main purpose of this file, make sure you write this down, guys. The main purpose of this file is to resolve host names that cannot be resolved any other way. So in this file is where we store all the server names that we're connecting to. That way when we type in this name, the file can resolve it. So it can also be used to resolve host names on small networks with no DNS server. Regardless of the type of the network the computer is on, this file should contain a line specifying the IP address of the loopback device, which can be 127.0.0.1, as localhost.local domain. So for more information, refer to the host man page. So look up the man page on the host, okay? So in these files, you'll have your host name. You're going to have the IP address of it. You can set some more function or more configurations up as well. This is how our server connects to other servers across the network. So the next file is /etc/resolve.conf. So this file specifies the IP addresses of DNS servers and the search domain. Unless configured to do otherwise, the network initialization script populates this file. For more information about this file, refer to the man page for resolve.conf. Okay. Next, we have /etc/sysconfig/network. This file contains specific routing and host information for all network interfaces. /etc/config/network-scripts/ifconfig, so ifcfg dash, and then the interface name is where you'll actually see the interfaces. So you're going to see a lot of files underneath this file or this directory here, and they're all going to end with a different ifconfig interface name. These are all different interfaces we have for the different switches and routers that we have set up. Okay. For each network interface, there's a corresponding interface configuration script. So each one has its own script inside of it. Each of these files provide information specific to a particular network interface. Okay. So guys, a network interface, if you look on your laptop or your computer, where you plug in your little Ethernet cord, that's the interface. Okay. So this is saying that on our server, we can have tons of different of these little plugs set up, and they all have their own different scripts and settings. So in summary, guys, we went over planning hardware and software considerations, site planning, installation methods and types, installation classes, partitions and logical volume manager, also known as LVM, file system overview, swap partition considerations and other partition considerations, the Linux bootloader, which is known as grub, software package selection, adding and configuring peripherals, which are printers and mouse and keyboard and things like that, printers and graphic controllers, basic networking configuration, and booting to recovery mode. In our next session, we're going to go over boot sequence, the systemd daemon, the systemd daemon, that's pronounced as daemon, the systemctl command, targets versus run levels, modifying a target, service unit scripts, changing system states, booting into rescue mode again, and shutdown commands. Guys, if you need extra help, please follow these links to go through our weekly and monthly plans available for private tutoring sessions for the system admin management. And then we can also have some private tutoring sessions set up for you to go over some Linux and Bash scripting. These are super helpful, guys. You're never going to learn better than having some one-on-one attention with someone and really hammering out some questions that you have. Thank you so much for joining me, guys. As always, go to codingbootcamps.com for more courses, and I look forward to seeing you in our next session. What is up, guys? Welcome to Session 3 of Introduction to Linux System Administration. As always, I'll be your instructor, Kevin Downs. Oops. So today we're going to be going over booting and shutting down Linux. So from our previous session, we went over planning hardware and software considerations, partitions, logical volume manager, LVM, file system overview, swap partition considerations, other partition considerations, the Linux bootloader known as grub, software package selection, adding and configuring peripherals such as printers, keyboard, and other things, graphic controllers, basic networking configuration, and booting to recovery mode. Today, we're going to go over the boot sequence, the systemd daemon, this is pronounced as daemon, the systemctl command or system control command, targets versus run levels, modifying a target, service unit scripts, changing system states. We're going to quickly touch on booting into rescue mode again, and then we're going to talk about shutdown commands. So let's get started with the boot sequence. This is important to know because it helps you understand how the Linux machine is actually booting up. And if something occurs during the boot process and you can kind of see where it messed up here in one of these boot sequences, you can kind of troubleshoot a little bit and figure out what went wrong there. So the first thing to start up is the BIOS, B-I-O-S, okay? This stands for Basic Input Output System, and this executes the MBR. MBR stands for Master Boot Record, and this executes grub. Remember, grub stands for Grand Unified Bootloader, and this starts up the kernel, and the kernel executes sbin init, so /sbin/init. Hey guys, if you remember back all the way from our first course, the kernel is what interfaces with the actual hardware on the system and the OS and all that. So once the kernel's up and running and we have /sbin/init started, init executes run level programs. So this is where the system really starts to fire up all its programs and user programs. So from here, run level starts going, and run level programs are executed from /etc/rc.d/rc*.d/. So, a daemon is a service that runs in the background and supervises the system, provides functionality to other processes. Okay, so the daemon is what's really running all the different processes in the background without us having to actually watch over them. Traditionally, daemons are implemented following a scheme originating in sysv Unix. However, in modern daemons follow a simpler yet more powerful scheme. Here they're going to be called new style daemons, and they're implemented by systemd. Systemd is a suite of basic building blocks for a Linux system. It provides a system and service manager that runs as PID1, so process ID 1, and it starts the rest of the system. Systemd provides aggressive parallelization capabilities, uses a socket and dbus activation for starting services, offers on-demand starting of daemons. It keeps track of processes using Linux control groups, maintains mounts and auto-mount points, and implements an elaborate transactional dependency-based service control logic. So systemd is what's controlling all these different daemons, okay? And remember, the daemons are what is controlling all the processes in the background. So systemctl command can be used to introspect and control the state of the systemd system and service manager. So systemctl command is how we're actually telling systemd what to do, how to run those processes, when to start and stop them, status, and other things like that. The fundamental purpose of an init system is to initialize the components that must be started after the Linux kernel is booted, traditionally known as userland components. The init system is also used to manage services and daemons for the server at any point while the system is running. So with that in mind, we'll start with some simple service management operations. The first one being systemd referring to run levels as targets. So we can display the new run level targets by issuing the following command. This guy here. So it's going to be ls space dash al space / lib or library / systemd / system / run level star. And guys, remember the star is going to list everything that begins with all of this text in front of it. So let's go ahead and open our VirtualBox. I have my terminal up here. Let me log back in. Alright, so I have my terminal here. And guys, real quick, actually let me exit out of this just so I can show you something. So on CentOS, we can't right click on our desktop and open the terminal. What we can do is we can just click on that activities and search CMD, which stands for command, and it'll pull the terminal up that way, okay? So I'm going to do an ls space dash al space / lib / systemd / system / run level.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Star or asterisk or splat. I'm going to hit enter. You see all these different file systems we have here. Run level 3, run level 4.target, run level 1. Okay. And you'll see all these arrows here. This means this is a symbolic link to another file. So here, this link is being linked to another file called poweroff target. And rescue target, multi-user target, etc. Okay. So let's go back to our PowerPoint. Remember, to get out of VirtualBox and get your mouse back, you have to hit right on the D-pad and then Control. And that'll free up your mouse. Okay. So that file is where we can see all the different run levels and targets. So let's look at those run levels. So 0 is the power-off target. 1 is the rescue target. 2 is the multi-user target. 3 is multi-user target. 4 is also multi-user target. 5 is the graphical target. And 6 is the reboot target. Okay. So how do we modify a target? So while the system is running, you can switch the target, otherwise known as the run level, meaning only one service as well as units defined under the target will now run on the system. So let's look at how to switch to run level 3. Let's run the following command. Remember, run level 3 is going to be multi-user target. So we're going to do systemctl isolate multi-user target. Give me 1 second. Okay, there we go. Let me clear my screen. Alright, so we're going to do systemctl isolate and multi-user, oops, spelled it wrong, multi-user dot target. I hit enter. So it's asking me to provide a password to do this. I'm going to go ahead and type in my password. Okay, so we saw we changed the run level target. So now it rebooted to change that target. So now it wants you to log in again, okay? So you're going to type in your login name, which for me was Kate Allis. There you go. See, now I'm in a multi-user target. So this looks different, guys, right? I lost my desktop and all that, right? So I want that desktop back. I want to boot back into a graphical target. So let's actually go to our PowerPoint real quick. Let's look at that. So to get back to a graphical target, we need to do systemctl isolate graphical.target. So let's go ahead and do that so I can get my beautiful GUI back. So systemctl isolate and graphical.target. Okay. So systemctl space isolate space graphical target. And again, it wants my password. In order to run this as a privileged user, I'll type that in. It's going to reboot. And voila. We have our graphical desktop back. Good as new. Alright, let's head back to our PowerPoint here. So we're actually going to look at how to make our own service unit. Okay? We're going to call it connection.service. Okay? To get to there, first we're going to go to etsy/systemd/system. Okay? Let's go ahead and just go there just to see what's there. We open a terminal again. So we're going to cd, remember cd is change directory, /etsy or etc/systemd/system. Okay, let's go ahead and list everything in there. You see we got all these different programs here. Okay, syslog.service, timers.targets once. We got a lot of different files here for service units. All right, we're going to make our own. Let's go back to our PowerPoint real quick. So first we're going to do a vim. We're going to edit and create a file named connection.service. And in that file, we're going to do unit, okay, to give it a heading, and then we're going to make the description equal to making network connection up. And then after is going to equal network.target, okay? Then we're going to make another section called service. We're going to do exec start equals root scripts conup.sh, okay? Then we're going to do install wanted by equals multi-user target, all right? So let's go and go back to our virtual box here. You guys can follow along with me here when we're doing all this. So we're going to do vim connection .service, and it's going to make this file inside this directory we're in. Okay. You guys remember when we're using vim to type things in, we have to get to insert mode, so I press I. We're going to name it bracket unit. We're going to go to the next line. We're going to do description equals making network connection up. And guys, you notice all these have different colors when we're typing it. So by putting in that heading, the file knows what these following things we type in are going to be assigned to. It's going to be the unit of this script. Okay. After, oops, That's a nice thing about Vim, is it colors it, so it helps you kind of understand what's going on. Okay, we're going to do space, bracket, service, do exec, start, equals, do /root, /scripts, /con-up.sh. So this is telling it where to execute from, and install. I'm going to explain all this a little bit more in depth once we actually get this on here. Wanted by, and make sure you guys spell this exactly how it's supposed to be. Remember, everything in Unix or Linux and Unix is case sensitive. So wanted by multi-user target. All right, I'm going to do one quick glance myself to make sure I did spell everything right and it's all capitalized how it should be. Alright, and then we're gonna save this. So we do escape to get to command mode, colon, right quit. Okay. You guys will see that at the bottom of my screen there. So right quit. Okay. Enter. Can't open file for writing. Oh. Right quit. Okay, let's try right quit exclamation point. Interesting. Oh, I think I know why. Okay. I think I need to do this as a privileged user. Interesting. Okay. So this brings up an interesting point. So I was going to switch to a privileged user on there. You can see where I tried to do sudo. And it tells me that I'm actually not in the sudoers file. Okay. That's something I'll have to add later on. But for right now, what we're going to do is we're just going to go ahead and switch to root. So if you guys remember how to do that from our last course, let me clear my screen real quick. We're just going to do su dash. And that's going to switch me to root. Now I'm root. Okay, let's try that again. Let's go to cd/etc/system/d/system. Yep, we're in the right one, so we're going to do vim. And it's going to be /etc, or sorry, connection dot service. And we're going to type all that in again, so unit. Description equals making network connection up, and oops, after equals network dot target do service, exec start equals /root /scripts /con-up.sh. Con-up means connection up. Install. Oops. There we go. And wanted by equals multi-user .target. Alright, this should fix the problem of it not wanting to save the file. So escape, right quit. Sure enough, yep, it just wanted me to be a privileged user in order to write that file. Okay. Let's go back to our PowerPoint. So we typed all in, we made that file. I'd like to explain a little bit what we did. So to explain what we did just above, we have created a unit of service type. You can also create unit of target types, and we have set it to be loaded after the network.target. Okay, you can understand that booting procedure reaches the target with a defined order. We want every time the service start to execute a bash script with the name conup.sh, which we are going to create. And I don't think we actually will create this, guys. I just wanted to kind of show you how you can create a service unit on your own. So the fun starts with the last part, which is the install part we saw. It tells that it will be wanted by the multi-user target. So if we enable our service, a symbolic link to that service will be created inside the multi-user.target.wants folder. So we're going to go ahead and try and enable it. We're going to do that by doing systemctl enable connection.service. Okay, let's go ahead and try it. See what happens. So systemctl enable and connection.service is what we named our file. Perfect. Yep. And you see there it says created symbolic link etc systemd system multi-user target.wants connection.service to etc systemd system connection.service. Okay. You guys see that there? It created that system or symbolic link. Okay. So let's go ahead and list the multi-user targets.wants folder just to see it under there to prove to you that that link was created. Okay. I'm going to clear my screen real quick. So I'm going to do ls multi-user target wants slash. Let's see what's under there. And actually, let's use another trick we learned. I'm going to call it connection. You guys remember grep is going to find everything in there that has the word grep in it. That way I don't have to try and find this by my eye. So we see there connection.service is listed underneath this, so a symbolic link was created. Let's do another thing here. See if I can see it. Well, okay, so it's not listing it in here. That's okay. No need to worry about that thing. Let's go back to our PowerPoint. So a Linux system may run in one of 7 possible states numbered from 0 to 6, as well as the single user state that letters S or capital S represent. So here's a description of those states. State 0 is the halt state, so when you switch a system to state 0, it will shut down immediately. State 1, known as the administrative state, allows access only to a super user. Using this state, a system administrator can perform various maintenance operations and installations without interference from others. State 2 is the part.
Thanks for watching. Please like and share this video.
Partial multi-user state. It allows multiple users to log in, but it disables remote file sharing. So state 3 is multi-user state as well. It allows multiple users to log in and enables remote file sharing. This is the default state for the command line interface. And we saw that earlier when I switched to 3. State 4 is unused. State 5 is the default state for graphical logins that use display managers such as GDM and XDM. If you choose to use graphical logins during the installation process, this will be your default state instead of 3, which would be the default otherwise. State 6 shuts down the system and reboots it. So note that when we did state 0, it only shuts it down. It's not going to reboot it. So state S, or capital S, is a single user state and restricts the number of logged in users to 1. So let's check that out. So if we want to change states, we can use the init command. So for example, we can do init lowercase s. That'll change single user state, or we can do init 0. Let me show you that real quick. We're going to change it to init s. Actually, real quick, let's do a run level command. Just see what run level we're currently at. We'll hit enter. And we're at run level 5. Okay? Which is, of course, the graphical one. We're going to do init lowercase s. It's going to reboot, take us to single user state. It's telling us to give the root password. Storing that single user state, which of course is going to be the command line interface as well as the rescue mode. So we're going to do init 5 to get back to our graphical state. And there we go, we're back at our graphical interface. Let's go back to our PowerPoint. So RescueMu provides the ability to boot a small Red Hat Enterprise Linux environment entirely from CD-ROM or some other boot method instead of the system's hard drive. So as the name implies, rescue mode is provided to rescue you from something that happened. During normal operation, your Red Hat Enterprise Linux system uses files located on your system's hard drive to do everything. Run programs, store your files, and more. However, there may be times when you're unable to get Red Hat Enterprise Linux running completely enough to access files on your system's hard drive. This happens a lot when you mess with the /etc/fs tab guys, which is where you mount all your drives. So using rescue mode, you can access the files stored on your system's hard drive, even if you cannot actually run Red Hat Enterprise Linux from that hard drive. So it's a good way to get in there and do some maintenance when your system's kind of locked up. So to boot in a rescue mode, you must be able to boot the system using one of the following methods. So either by booting from CD-ROM, another boot device or media such as USB flash drive, or by booting the system from Red Hat Enterprise Linux CD-ROM number 1. So guys, once you have booted using one of the described methods above, you can enter the keyword rescue as a kernel parameter. For example, for a 86 system, so by 86 architecture, type the following command in installation boot prompt, Linux rescue, and it'll put you in that rescue mode. To shut down your system for a terminal session, you can sign in, switch to root or SU, and then you can type in /sbin/shutdown-h now. It's going to take a couple moments, but this is going to terminate all processes and it's going to shut down your system. I can show you that real quick. Since we're at the end of our session here, let's go ahead and shut our machine down. Let's log in twice, I guess. Log in. Oh, weird. Alright. Interesting. Looks like our machine did something weird. Let's try this. Huh. Alright, give me 1 second, guys. I don't know what's going on with my VirtualBox here, but it's kind of locked up. I'm going to power it down a different way. Alright, well that's firing back up, so I can show you guys how to shut it down on the terminal. Let's talk about what we learned. So today we went over the boot sequence, the systemd daemon, system control command, targets versus run levels, modifying a target, service unit scripts, changing system states, booting into rescue mode, and shutdown commands. Next session, we're going to go over identifying software packages, using RPM to manage software, using yum to manage software, installing and removing software, identifying devices, displaying device and system info such as PCI and USB, plug-and-play devices, and device configuration tools. Let's see if our VirtualBox is booted up here again. Weird. Okay, give me 1 second, guys. There we go. Okay. Let's see if it'll let me in here. If not, I'm gonna have to do some troubleshooting of my own and figure out why it won't let me log in. There we go. Not sure what was going on before, but nothing the old on-off trick can't fix. So to actually shut down our machine from the terminal, we do /sbin/shutdown-h now. That'll shut down the machine from your terminal. Give it some time, and then it shuts down. Alright, let's go ahead and conclude today's session. So thanks for joining me, guys. As always, if you need a little bit of extra help, go ahead and follow these links for some private tutoring sessions. We have weekly and monthly plans, and if you want some additional help, we have one-on-one sessions. And we can do that for Linux and Bash scripting. Thanks so much for joining me, guys. Looking forward to seeing you in our next session. Hey, what's up guys? Good morning, good afternoon, or good night depending on what time you are viewing these videos. Welcome to session 4 of Introduction to Linux System Administration. As always, I'll be your instructor, Kevin Downs. Today's session, we're going to be covering managing software and devices. Last session, we went over boot sequence, the systemd daemon, the systemctl command, targets versus run levels, modifying a target, service unit scripts, changing system states, booting into rescue mode, and shutdown commands. Today, we're going to be going over identifying software packages, using RPM to manage software, using yum to manage software, installing and removing software, identifying devices, displaying device and system information such as PCI and USB, plug-and-play devices, and device configuration tools. Let's start off with how to identify software packages. So if you prefer to use a graphical interface to view and manage packages in your system, you can use the package management tool, which is also known as pyroot. So this tool allows you to perform basic package management of your system through an easy-to-use interface to remove installed packages or download and install packages compatible to your system. It also allows you to view what packages are installed in your system and which ones are available for the download from the Red Hat network. In addition, the package management tool also automatically resolves any critical dependencies when you install or remove packages in the same way that the RPM command does. Okay, so let's say you install a package and it also needs some other things to be installed with it. It's going to go ahead and install whatever it needs to go along with it. Okay, guys, I would caution you to get used to using things in a graphical interface. As a sysadmin, you are rarely going to be doing stuff in the desktop or the GUI. You're going to pretty much live in command line. So I'll really get familiar with how to do everything in command line, okay? So let's take a look at our next slide. This is how we're going to be doing stuff in command line. So RPM is how you do stuff on the command line. RPM has 5 basic modes of operation, not counting the package building. So there's installing, uninstalling, upgrading, querying, and verifying. The first few kind of speak for themselves. Querying is how we look to see if a package is on a system. And verifying is how we make sure that the package is actually installed on the system. So this section is going to contain an overview of each mode. For complete details and options, I would do an rpm-help to really see how to actually use that command. So before using any RPM packages, you got to know where to find them. An internet search will return many RPM repositories, but if you want to see a full list built by Red Hat, they can be found at the following locations. First one's going to be a Red Hat Enterprise Linux CD-ROM, which again is not something that's typically used anymore. So the much better place to look is going to be www.redhat.com/apps/support/errata. Okay, and that's where they're going to have all the repositories and you can find all the different packages you're going to need. Okay. So yum is how we're actually going to install and uninstall things, okay? So yum is the primary tool for getting, installing, deleting, querying, and managing Red Hat Enterprise Linux RPM software packages from the official Red Hat software repositories, as well as other third-party repositories, okay? So yum is used in Red Hat Enterprise Linux 5 and later. So versions of Red Hat Enterprise Linux 4 and earlier actually use something called up-to-date, okay? The yum command cheat sheet for Enterprise Linux contains a reference card outlining the common use cases for the yum command. So if you just Google, a yum command cheat sheet, it's going to tell you a bunch of different ways to use that yum command, and that's really the best thing to do. You can print that out, and that way it'll give you a little bit of guide to look at each time you're trying to do a patching update or something like that. So you can use RPM or yum or DNF if you're using a different Linux distribution to remove software installed in your system. You can also use APT and DNF in various Linux distros. Guys, in Red Hat and CentOS, what you're going to be using is you're going to be using RPM and yum. That's the ones we're going to be using for that, okay? For Ubuntu, in our last course, we were using APT, okay? So it really depends on what Linux distribution you're using as far as what commands they use to update and install packages. So let's go ahead and look at identifying devices. So the best way to list anything Linux is to remember the following ls command. So ls is a very good command to list a lot of things, not only just files, but as well as other things. So first at ls is to list the files in the file system. We've seen this used many times. There's also ls block, which lists the block devices, which are going to be your hard drives. ls PCI, which is going to list the PCI devices. Okay. LSUSB, which will list USB devices, LSDev, which is going to list all devices, and mount to see mounted disks. So let's go ahead and look at those real quick. Let me fire up my machine here. You guys can go ahead and follow along with me. Give me 1 second, just start my machine up. Alright, let's go ahead and get logged in. Let's get our command line going. Alright, so we're going to do that first one, which is ls block. Ls block is nice because it actually not only shows you your different hard disks, but it also shows you what partitions are on them. Okay, so that's really nice. Now the way you can see your different partitions is df-h, but you'll notice that it doesn't actually show you any of the partitions. Or I'm sorry, not a df-h, it would be fdisk-l, I believe. No, yep, wants me to do that. Okay, so just ignore that for right now. So we can just do ls block. Oops, lsblk. There we go, ls block, and I'll show you all your different partitions. So that just stands for list block devices. Okay. The other one was lspci, so list PCI. So it's going to show you all your different PCI devices there, which are going to be like your peripheral devices, such as mouse and keyboard and things like that. Alright, let me go ahead and clear my screen. So let's do LSUSB. And you'll see there I don't really have much plugged in because I don't have many things plugged into my computer right now. I do have a wireless mouse plugged in. LSDev was our next one. So list dev devices.
Thanks for watching. Feel free to add your questions as comments down below.
So it's actually not finding that command, so maybe a package we're missing. And then we do mount to show all of our mounted devices. Okay. So this can look like a lot of gibberish, guys. So this command is best used with grep if you're trying to find a specific mounted drive or file system. Okay. Or an easier way to do that is the command I did earlier, which was df-h. Okay, and you'll see here it'll show you your file systems and what it's mounted on. Let's head back to our PowerPoint. So get our next slide here. So like for everything, there are plenty of commands to check information about the hardware of your Linux system. Some commands report only specific hardware components like CPU or memory, while the rest cover multiple hardware units. So we're going to take a quick look at some of the most commonly used to check information and configuration details about various hardware peripherals and devices. The list includes LSCPU, HWinfo, LSHW, DMI decode, LSPCI, and others. So let's look at our first one here, which is going to be the LSPCI command. This will show the device ID of your network card or any other PCI device. Depending on your system, you may be able to run this command without having to be root first. So we're going to try it, and we're also going to add the flags NVV on it. So let's try it again. LSPCI. So let's all our PCI devices there. Let me clear my screen. We're going to run it again. So this time we're going to do it with the NVV command. Actually, let's do it just with that, and then let's do it again with the flags so you can see the difference. So you see it gives you a lot more info on it when we do it that way. It's giving you a lot of more details on it. So that's usually what flags do on commands, is they alter what the command shows and gives you more info. Okay, let's clear our screen. So when we do the NVV command, This will display LSPCI output in verbose mode with numbers without performing a lookup in the device ID list. So V stands for verbose. If you add a second V on, it's going to give you even more options. You can actually add a third V on there to give you as much info as possible. Let's look at our next one, which is going to be LSCPU, which reports info about the CPU and processing units. This one doesn't actually have any flags on it that we can use. So we're just going to do a LSCPU. So list CPU. And you'll see here it's going to list all of our CPUs, as well as some info about it. Oops. There we go, right there. So it's telling you we got an 86 by 64 architecture on the CPU. Okay. It has 32 and 64-bit modes. We only have one CPU. There's one thread per core, one core per socket, and one socket. Okay. Tells you who the vendor is. Model name. So it's an i7 core processor in my laptop here, as well as some other info. Okay. Let me go ahead and clear my screen. Let's head back to our PowerPoint. We also have LSHW, our list hardware, which is a general purpose utility. It reports detailed and brief information about multiple different hardware units such as CPUs, memory, disk, USB controllers, network adapters, and more. So LS hardware extracts the information from different /proc files. So let's run that one real quick. LSHW, list hardware. And we're going to get a ton of info. Okay. Again, all these commands are best used with grep, because typically if you're going to be using these commands as a sysadmin, you're looking for very specific info, and you already know what that info is. You just need to see what the associated number is. So maybe I'm looking for, what kind of CPU is this? So I'm going to type in, LS CPU pipe grep model, and it will just tell me the model of the CPU. So typically that's how you're going to be using these commands. Let's look at our next command here, which is going to be hardware info, which is another general purpose hardware probing utility that will report detailed and brief information about multiple different hardware components and more than what LS hardware reports. So let's go ahead and run that real quick. Let's clear my screen. Hardware info. Oh, okay, so this command's also not found, so maybe we're missing a package. So let's move on to our next command, which is going to be LSSCSI. So LSSCSI, pronounced as SCSI, which stands for Small Computer System Interface, lists all the SCSI and SATA devices like hard drives and optical drives. So let's do an LSSCSI on our virtual machine. LSSCSI. There you go. It's going to list a couple things we have on here. So we have a disk. And we only have one disk, so you only see one here. STA, remember. First disk, only one partition. And we have a CD-ROM. Okay. Let's go back to our PowerPoint. Let's look at the next one, which is going to be LSUSB. So LSUSB shows the USB controllers and details about devices connected to them. By default, brief information is printed, but you can use the verbose option to print detailed information about each USB port. Guys, that -V option can actually be used on a lot of things. So feel free to use that with as many commands as you like, just to see if the -V option is available. We just use it without, and then we'll use it with the verbose option. And you see we get a lot more info when we use the verbose option. Okay. Let's move on to our next one here, which is going to be LS block, which we actually looked at earlier, so I won't demo it for you again. But again, this one's listing out all block devices, which are the hard drive partitions and other storage devices like optical drives and flash drives. We have the df command, which I actually showed not too long ago. This reports various partitions, their mount points, and the used and available space on each. So I will demo that one again, just because we are actually, oops. So yeah, you see that here, guys, df. So I'm going to demo that one for you again. So df without the -H option will list everything, but you'll notice it's not in a very human-readable format here, okay? So I always run it with the -H option. And now you'll see it's in much more human-readable terms. It's all in megabytes and gigabytes, okay? So it shows your file system, the size of the file system, how much you're using on that file system, how much is available, and it also breaks it down into a percentage. So you'll see on this file system there's 8 gigs, 4.4 gigs is used. This is how much is available, so about half of it's being used. Okay? Let's clear our screen. Go back to our PowerPoint. We're going to look at fdisk. So guys, fdisk is how you actually format your hard drives. Okay, so fdisk is a utility to modify partitions of hard drives, and it can be used to list out the partition information as well. So this is how, if I put a new disk on my computer, I want to partition it out. I'm going to run fdisk, the disk name. It's going to actually take me through an interactive way to partition that disk. We're not going to go into that right now. For right now, I just want you to be familiar with that option. There's also gdisk that can be used, and it's similar, except that is setting up GPT partition tables, which will support a lot more partitions. And there's also fparted, which is the original way to do it. However, fparted requires a little bit more intimate knowledge of the disk, because you're actually going to have to know the start and end point of disk sectors and things like that. So fdisk and gdisk are really the best ways to do it. Let's talk about plug-and-play devices. Plug-and-play provides a means of detecting and setting resources for legacy or otherwise unconfigurable devices. The Linux plug-and-play layer provides these services to compatible drivers. So some examples of plug-and-play devices, guys, are computer monitor, external hard drive, gamepad or joystick, keyboard, mouse, USB flash drive, or webcam. So guys, these are things you can just simply put and plug into your computer, and they're going to be available to use just like that, okay? So you don't have to do any setting up or configuring of them. Next, we're going to look at device configuration tools. So connecting your Linux computer to network is pretty straightforward, except when it is not, okay? Meaning, networking is simple, except when it's not simple. So there are two ways networking startup services. There are two network startup services: the venerable network startup and the controversial network manager. So most of the other files in the etc/sysconfig/network-scripts directory are scripts used to start, stop, and perform various network configuration activities. And each configuration file is bound to a specific physical network interface by the MAC address or the interface. So guys, MAC address is short for Media Access Control Address, okay? So this is the worldwide unique hardware address of a single network adapter, okay? So each interface has a MAC address, and this tells us exactly where it was made, okay? Again, we're not going to go too much into these networking setup and startups because as sysadmin, you should need to really know general concepts. Unless you want to be a network administrator, then there's a whole other world out there of network stuff that you can look up and learn about. So in summary, guys, we went over identifying software packages, using RPM to manage software, using Yum to manage software, installing and removing software, identifying devices, displaying device and system info, plug-and-play devices, and device configuration tools. Looking forward into our next session, we're going to be going over setting up policy, user file management, managing the Etsy password file, the Etsy shadow file, the Etsy group file, the Etsy G shadow file, adding users, modifying user accounts, deleting user accounts, working with groups, setting up user environments, and finally, login configuration files. Guys, if you're struggling, you're having a little bit of a hard time catching on these concepts, please follow these links for private tutoring sessions for system administrator management. There are weekly and monthly plans. Or if you need some private tutoring sessions for Linux and Bash scripting, go ahead and follow this link here. Thank you so much for joining me, guys. I am looking forward to seeing you in Session 5. Hey guys, welcome back to Session 6 of Introduction to Linux System Administration. As always, I'll be your instructor, Kevin Downs. Today, we're going to be going over managing users and groups. Last session, we went over identifying software packages, using RPM to manage software, using Yum to manage software, installing and removing software, identifying devices, and displaying device and system info, such as PCI and USB. Today, we're going to be going over setting policies, using file management, the /etsy/passwd file, and the /etsy/shadow file, and the /etsy/group file. We're also going to go over the etsy/g shadow file, adding users, modifying user accounts, deleting user accounts, working with groups, setting user environments, and login configuration files. Let's go ahead and get started with setting policies. So a password policy sets certain standards for passwords such as the password complexity and the rules for changing passwords. A password policy minimizes the inherent risk of using passwords by ensuring that they meet adequately complex standards to thwart brute force attacks, and they are changed frequently enough to mitigate the risk of someone revealing or discovering a password. So there are three main ways that we can define the password policy. First is going to be strength or complexity and requirements. Second is going to be history, and finally account lockout. So we can set requirements for how long the password has to be and how many different characters have to be in it. We can set how long passwords are remembered so that you can't just change the password to one used before. So we can say, remember the last 10 passwords, and that prevents anyone from reusing passwords. And then we can also lock an account after so many failed attempts, okay? And those can all be set in different configuration files. So below are some commands that are typically used for user file management: cd, pwd, ls, less, touch, make directory, move, copy, remove. We've looked at all of these commands here, okay? And remember, these are used for file management of users. Not users themselves, but file management of the users, okay? Today we're going to actually look at how to manage the users themselves. Let's go ahead and look at some of these files that are used to manage the passwords and users. First one is going to be etc passwd. So this is a text file that contains the attributes of each user or account on a computer running Linux or another Unix-like operating system. So the permissions for etc password are by default set so that it is world readable, meaning that it can be read by any user on the system. The file can be easily read using a text editor such as gedit or vi, or with a command such as cat, which is commonly used to read these files. And that's how I typically look at these files, is through cat. Or if I want to actually have a little bit better output to look at, I'll use vim. So we would just do cat/etc/password to see what's in these files. And guys, we've actually looked at this before, but I'll go ahead and show you again what that file looks like. Do a Control-L, we'll do cat/etc/passwd. Alright, and then we see a lot of output here. Okay, each line is going to be a different user, and it's going to have different traits to it. So we see here root, its password, min-max days, groups, its shell, and its home directory. Okay, so it gives a lot of info about the users. Let's go back to our PowerPoint. So each line in etc password represents a single user. The first line listed is root, which I showed you. And this has complete power over every aspect of the system. Root.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Is the super user. It rules all. So this is followed by system-defined groups, meaning that they aren't necessarily users. They're actually I guess the best way to put it is they're just accounts on the system that control certain things on the system, okay? Which that says here, these are accounts that are required for proper installation and update of system software. So in order for some of these daemons to run things on the system, they need to have an ID and a way to access the system. So the lines at the end represent real people who use the system. So real quick, let me see if I can show you. Yeah, there you go. You see at the very end there, you see kdowns. So that's going to be me. My password, my home shell, and my home directory, okay? So at the very end is where the actual users are. So let's take a look at our next file, which is going to be the etc/shadow file, okay? Traditional Unix systems keep user account information, including a one-way encrypted password and a text file called /etc/password, okay? Which is the file we looked at. So since this file is used by many tools, such as ls, to display file ownerships, etc. by matching user ID numbers with the user's name, the file needs to be world readable, okay? However, this is kind of a security risk. If we're storing our passwords in a world readable file, then anyone on the system can see the passwords, okay? So we have a much better method of actually storing passwords, and that's going to be the shadow password format. So with this traditional method, the method stores account information in an etc password file in a compatible format. However, the password is stored as a single X. So let me show you that real quick. So you'll see there right next to all IDs and names, you see an X. Okay, so that's the password, but that's just a placeholder for it. Okay. So in a second file called /etc/shadow, this is where it contains the encrypted password as well as other information such as account or password expiration values. The etc shadow file is readable only by the root account and is therefore less of a security risk. So let's check that file out. Let's clear my screen here. We're going to do cat/etc/shadow, and shadow is kind of, mysterious. Oops, so I need to be root user or super user to do that. So I'm going to go ahead and switch over. See, that's another security measure for this, is that it's not a world readable file. So you have to be root to do it. So that means even if someone was on your system, they would have to be root to be able to read it. Alright, so now we see on here, let's go to my user right here. So you can see there, my user's at the bottom, and then we have this huge string of numbers and letters and symbols here, okay? That's my password, but it's encrypted. So even if you get into this file, you can't see my password in plain text, okay? You'd actually have to run an algorithm to unencrypt it, which would take time and knowledge to do so. So setting up passwords in this way is a much better way to secure your system. Let's look at the etc group file. This is a text file which defines the groups to which users belong under. Linux and Unix operating systems use this method. So under Unix Linux, multiple users can be categorized into groups. Unix file system permissions are organized into 3 classes: user, group, and others, which we've looked at. The use of groups allows traditional abilities to be delegated in an organized fashion, such as access to disks, printers, and other peripherals. So this method, among others, also enables a super user to delegate some administrative tasks to normal users. So guys, I can put a user in a group, and then I could say that group has certain privileges to files, certain access to certain directories, or maybe they can only run certain commands. So that allows me to more efficiently kind of administer my users on a system, as opposed to going to each user one by one, saying this guy can do this girl can do that. I can just make a group, give it certain permissions, and then throw everyone I want in that group to have those permissions. So let's look at the etc shadow file. As you might imagine, this is similar to the etc password, etc shadow file. So the etc shadow file is readable only by the root user and contains an encrypted password for each group, as well as group membership and administrative information. Just as in the etc group file, each group's user information is in a separate line. So let's look at both those files. Let me clear my screen. We're going to do etc group first. So we'll see all the groups listed there, and then the little X for the placeholder. And let me clear my screen, and let's do a gshadow file now. And then you'll see all the groups on there, and then with the exclamation point, okay? So this means not, so it does not have a password. Bang in Linux usually, bang is another word for exclamation point in Linux. This usually means not, okay? It does not exist. Clear my screen. Another little helpful command, guys, is the groups command. Oops, forgot the S. This will actually list all groups on your system. In this case, there are no groups other than root. So that's handy if you're trying to think of what groups on your system. You can run the groups command. I'll actually add that in here. So let's go ahead and move on from here. So we want to go ahead and look at managing users here. There are times when a Linux system administrator is asked to create user accounts on Linux with some specific properties, limitations, or comments. In Linux, a user add command is a low-key utility that is used for adding, creating user accounts in Linux and other Unix-like operating systems. The add user is similar to user add command because it is just a symbolic link to it. So this command, if used, will just point back to this user add command. However, this command is not always available on systems. So when we run user add command in Linux terminal, it performs the following major things. First, it edits etc password, etc shadow, etc group, and etc gshadow files for the newly created user account. It also creates and populates a home directory for the new user, and it sets permissions and ownership to the home directory usually determined by a umask. So basic syntax of the command is user add, and then we have options, such as flags and other things, and then we have the username, okay? So when we want to modify a user account, so an account already exists and we want to modify certain things on it, we're going to use a command called user mod, okay? This is similar to user add or add user, but it alters an already existing account, okay? So after creating user accounts, in some scenarios, we may need to change attributes of an existing user, such as the user's home directory, login name, login shell, password expiry date, etc. In this case, we're going to use user mod command. So when we execute user mod command, the following files are used and affected: etc password, etc shadow, etc group, etc gshadow, and etc login defaults. Okay, let's actually go ahead and look at that etc login defaults file. So this file defines some certain things for us. Important things too. So we see there at the bottom, that's really the main things we want to look at. We see password max days, min days, password minimum length, and password worn age. So if you read the description of those, it says pass max days is maximum number of days a password may be used. Pass min days, minimum number of days allowed between password changes. Pass minimum length, which is minimum acceptable password length. And then pass worn age, which is number of days warning given before password expires. So if we set like pass worn age to 10, it's going to give you a 10-day notice before the password needs to be changed. So ways we can do that via the pass or user mod command, we can do user mod dash lowercase m, which is going to be minimum amount of days. Or we can do max, which can be the max amount of days, and I can do that for mine. K downs. All right. Let's set it to like. Actually, let's change the warning on it. I'm not totally sure. Let's see. Oops. Not seeing it on here, but here's all the different options you can use on that user mod command, guys. So I just did a user mod dash dash help. Okay, so this allows you to alter certain things with the user account. Let's head back to our PowerPoint. And actually, guys, before I do that, I believe it's actually is change age for, and it'd be dash m or lowercase in capital case M to change the password max and minimum days on my account. Anyways, that's not important right now. Let's go ahead and look at the rest of our user account modifications here. So the last one you need to think about is the user delete command, which deletes a user account and related files from the user account. So this command must be run as root, along as with the other commands. The user mod and user add have to be run as root, okay? And the syntax is as follows. So we'll do a user delete and then the username. We can also add some options and flags in between username and user delete to modify what user delete's doing. But the real important one here is going to be the dash R, okay? If you really want to get rid of everything on a user, you want to do dash R. This will actually get rid of his home directory and all files as well. Okay, so this is what you really should do if you want to get rid of a user and everything associated with it here. This dash R, which of course means recursive. Okay. Alright guys, last thing we're going to look at for today is how to manage groups. So the control of user groups is a core element of Red Hat Enterprise Linux System Administration. So the user of the system is either a human being or any account used by specific applications identified by a unique numerical identification number called a user ID or UID. Okay? Users within a group can have read permissions, write permissions, execute permissions, or any combination of read, write, execute permissions for files owned by that group. Every time a shell session spawns, a process takes place to gather and compile information that should be available to the shell process and its child processes. It obtains the data for these settings from a variety of different files and settings on the system. Basically, the environment provides a medium through which the shell process can get settings and in turn pass these on to its child processes. So the environment is implemented as strings that represent key value pairs. If multiple values are passed, they're typically separated by colon characters. So what we're talking about here, guys, is setting up environments for users. Okay, we're setting certain rules up and regulations for the environment when they log in. So how we can kind of manage that is in their etc profile file, okay? So this file contains the system default settings for users who log in using the born shell, which is /bin/sh born shell. When these users log in, the born shell runs the commands in this file before giving the shell prompt to the user. Most of the commands are variable assignments which configure the behavior of the shell. So it says that etc profile sets the environment variables at startup of the bash shell. And the etc profile.d directory contains other scripts that contain application-specific startup files, which are also executed at startup by the time of the shell. So if we add things, we're going to be putting it in this profile.d, okay? And the system will run that as well in combination with this file and set up the environment appropriately. Let's go ahead and take a look at that file. Let's see if it's set up on our virtual machines. If it is, it's not going to have much in it. I spelled all sorts of things wrong there. etc/profile. And you'll probably have to run this as root. Okay, so here we go. We see different variables and settings in here. And guys, don't worry too much about what this says here. There's a lot of bash scripting going on here. So this may not be familiar with you. However, if you've done scripting before, you'll be familiar with what some of this says. So we have some if statements. Okay. We have some other stuff going on here. All you need to know about this is that it's setting up the environment for the shell. Okay. Let's go ahead and do cat, and we'll do /etc/profile.d. I don't think there'll be any. Oops. I don't think there's going to be anything in here, but there might be. So let's see. Man. I gotta spell it right though, otherwise it's not gonna work. PR. There we go. Okay, so there are some files in here. Now, really what I'm seeing here is the color of the terminal, all these color scripts. Gawk are commands.
Thanks for watching. Please like and share this video.
Less is a command. Shell.local is the local shell. Them is the VI editor enhanced, okay? So we have some additional settings for when the shell starts up. Let's go ahead and finish out our PowerPoint for today. So that's what those files look like and what they do. So in summary, we went over setting policies, user file management, the etc password file, and the etc shadow file, and the etc group file, the etc shadow file, adding users, modifying users, deleting users, working with groups, setting user environments, and login configuration files. Next session, we're going to go over file system types, conventional directory structure, mounting a file system, the /etc/fs tab, or file system tab, special files, hard link files, soft link files, creating new file systems with mkfs, the lost and found directory, repairing file system with fs check, the journaling attribute, and file and disk management. Be sure to follow these links for extra help. There are weekly and monthly plans available for private tutoring sessions for system administrator management, and there's also private tutoring sessions available for Linux and Bash scripting. Thank you so much for joining me, guys, on session 5 here. Looking forward to seeing you in session 6. Hey guys, welcome to session 6 of Introduction to Linux System Administration. As always, I'm your instructor, Kevin Downs. Today, we're going to be going over the Linux file system. In our last session, we went over setting policies, user file management, the etc passwd, etc shadow, etc group, and etc shadow files. We also went over how to add a user, modify user accounts, delete user accounts, working with groups, and setting user environments. Today, we got a lot to cover. We're going to be going over file system types, conventional directory structure, mounting a file system, the etc/fs tab, special devices, inodes, hard links, soft links, creating new file systems with makefs, the lost and found directory, repairing file systems with fscheck or fsck, the journaling attribute, and file and disk management. And we'll actually show you how and walk you through creating a file system on a new device. So let's take a look at some file system types here. Don't worry too much about all this info here, just be familiar with it, and this is a good file and graph to have on your own records. So some file system types we have are FAT16, FAT32, NTFS, ext2, ext3, ext4, RiserFS, JFS, XFS. Okay, XFS is probably the newest and latest one. Okay, FAT16 and 32 are kind of legacy and old. Okay, and NTFS is going to be for Windows compatibility. ext2 is a little bit older, and ext3 and 4 are still in use, and I still see them used pretty frequently. Something to know about ext2 is that it is not online resizable, meaning that you would actually have to turn your computer off to resize that file system, whereas everything else you can resize it on the fly, which is nice. Moving on, we're going to take another look at how our directory structure works. So at the very top we have root, and then below that we're going to have different files: bin, boot, dev, etc, home, lib, media, mount, and then underneath of those we're going to have more such as opt or opt, root, sbin, srv, temp, user, or usr. Again, this is not user. Commonly people call it user. It is not user. It's Unix shared resources. Okay, so usr. var, and then underneath that we can have even more files. Okay, so each one of these is kind of stored under a file system, guys. So file system is what holds, it's like a container for directories and files. So we'll have a file system that actually holds all of these. Okay. So if we want to mount a file system or to attach a certain file system, we have to use the mount command in the following form. So we'll do mount, the options we want to add to it, the device, and then the directory we're mounting to. And the device is usually going to be the disk that's going to hold this file system. So the device can be identified by a full path to a block device, for example, /dev/sda3, which, remember guys, this means this is going to be the first disk and the third partition. Or we can use a universally unique identifier, or the UUID, for example. The UUID is going to be equal to this long number here. So typically people will just go by this way of naming the device. But sometimes we can use the UUID, and that way we know for sure what we're using. Or we can use a volume label, for example, label equals home. Okay, this isn't typically used, but if you know the system well enough and you have a lot of familiarity with Linux, this is much easier to do, and you can add labels to your disk, device, and partitions. Take note, guys, that while file system is mounted, the original content of the directory is not accessible. So you have a directory, you have info on it, and then you go to mount it. None of that is going to be visible while it's mounted, so keep that in mind. So we're going to take a look at the etc/fs tab next. So guys, the FS tab is your operating system's file system table. In the old days, it was the primary way that system-mounted files were mounted automatically. Nowadays, however, you can plug in a USB drive of any kind and it'll just pop up in the Nautilus like it does in Windows and Mac OS. But once upon a time, you had to manually mount those disks to a specific folder using the mount command. This held true for DVDs, CDs, and even floppies, if you guys can remember those. The FS tab is located at /etc/fs tab, and I'm actually going to show you that file real quick. So this is still used. I use this frequently in the work I do for IBM. This is how we automatically mount disks. So when the system boots up, these disks will come up automatically with the system, as opposed to having to type the mount command every time we want to mount all the files. Let me get my terminal pulled up here. I'm just going to do a cat /etc/fs tab. And there you go. You don't see much in here. You see about 3 diffs. This one, dev mapper cl root. You see this one here, the UUID number. And we see dev mapper cl swap. So this is my root file system. This is my swap. And this looks like this is my boot file system. Okay, so not much here in this file system tab. Be careful when editing the file system tab. If anything's off when your system comes up to boot, it's going to boot into emergency mode if something is off. So we want to be careful when editing that file. So at our next PowerPoint here, we have a device file as an interface file, as an interface for a device driver that appears in a file system as if it were an ordinary file. In Unix-like operating systems, these are usually files that are found under the dev directory and are also called device nodes. So for a more definitive but usually less easy answer, look in the kernel documentation. First, you need to determine whether device is a block device or a character device and its major and minor number. Very briefly, guys, we're going to talk about inodes. It's something we've covered before, but as a refresher, an inode is a data structure on a file system on Linux and other Unix-like operating systems that stores all the information about a file except its name and actual data. So a data structure is a way of storing data so it can be used efficiently. So this is important to know because we're about to talk about hard links and soft links, and if you remember, we use ls-i to list an inode number. There we go, an inode number. So the inode is important to know because we're about to talk about hard links and soft links. So in Linux, when you perform a listing in a directory, the listing is actually a list of references that map to an inode. So when you create a hard link, a hard link is yet another reference to the same inode as the original file. A hard link allows a user to create 2 exact files without having to duplicate the data on disk. However, unlike creating a copy, if you modify the hard link, you in turn modify the original file as well as they both reference the same inode. Hard links have some limitations, as in most but not all Unix Linux distributions. Hard links cannot be created for directories. Hard links are also not allowed to cross file systems, so inodes are unique to each file system. Because a hard link is a second reference to the same inode, they cannot be used across multiple file systems. So if we have a hard link on one file system, it can't reference a file or a hard link on a separate file system on our computer. On the other end, we have soft links. So a symbolic link is similar to a hard link in that it is used to link an already existing file. However, it is very different in its implementation. A symbolic link is not a reference to an inode, but rather a pointer that redirects to another file or directory. So a symbolic link is also a soft file link. Symlinks do not have the same restrictions as hard links, as symlinks can be used to reference a file in another file system. Symlinks can also be used to point to a directory. Okay. So let's take a look at the makefs command. So the makefs command, or make file system command, is used to create a file system, i.e. a system for organizing a hierarchy of directories, subdirectories, and files, on a formatted storage device or media, usually a partition or a hard disk drive. Makefs is actually just a front end for the various specific file system creation programs that are available in Linux, such as make2fs, makefs.ext3, and makefs vfat. And ext3 and 4 are the typical ones we're going to be using. So the specific program is searched for first in several standard directories such as sbin, sbinfs, and sbinfs.t, and etcfs. The precise list is defined when makefs is compiled. Then in directories listed in the path environment variable lastly, which lists the directories that the system searches for an executable program. So the syntax for makefs is makefs with various flags such as -V or -T, which will have to put the file system type, the file system option, and then the file system itself. So really we're going to just do makefs and then the file system to make it a file system. There's a lot of flags and options, as you can see here, that you can put onto it to alter what it does. Okay. Next we're going to talk about the lost and found directory. The lost and found folder is part of Linux, Mac OS, and other Unix-like operating system. Each file, that is each partition, has its own lost and found directory, and you'll find recovered bits in corrupted files here. So when we run that fscheck command, which is short for file system check command, it examines your file system for errors. fscheck may be bits of orphaned or corrupted files in the file system. If it does, fscheck removes those corrupted bits of data from the system and places them in that lost and found folder we were just talking about. So for example, if you abruptly shut your computer down while it's running and the files are being written to a hard drive, the fs tool may automatically examine your file system next time you boot your computer if it finds any corrupted data it places in the system's lost and found folder. So let's check that out real quick. I have my system pulled up here. Let's see if I can find the lost and found folder here. Let me clear my screen real quick. Do an ls. I don't have the lost and found folder. Let's go ahead and go to... Actually, let's go all the way. Let's just go home. There we go. Alright, so it doesn't look like we currently have the lost and found directory on here. Let me check one more place. Alright, so it might not actually be set up on this machine yet. Let me see if I can do a cd/lost or lost. Okay, so it's not actually set up on this system yet. But let's go ahead and run that fscheck command. Oops, fscheck. And then this is what I wanted to show you guys. So it's going to check that disk. However, if you try to do it while it's mounted, it's going to really damage your file system. Okay, and luckily this gives you a warning before you do that. So if you guys run that command on a system that's mounted, it's going to really mess it up. Okay, so I'm going to go ahead and click no here. And that's what I wanted to show you guys, is that you don't want to run that fscheck on a file system that's already.
Thanks for watching. Feel free to add your questions as comments down below.
Mounted. Okay. Let's head back to our PowerPoint. Now let's talk about the journaling attribute. So a journaling file system is a file system that maintains a special file called a journal that is used to repair any inconsistencies that occur as the result of an improper shutdown of a computer. Such shutdowns are usually due to an interruption of the power supply or to a software problem that cannot be resolved without rebooting. Journaling file systems write metadata, which is different from inode data, because metadata is just data about files and directories, so actual data inside of it. This data is written into the journal that is flushed to the HDD or hard disk drive before each command returns. In the event of a system crash, a given set of updates may have either been fully committed to the system, which means it was written to the hard drive, in which case there is no problem, or the updates will have been marked as not yet fully committed, in which case the system will read the journal, which can be rolled up to the most recent point of data consistency. Alright guys, let's go ahead and close out our session for today, and let's talk about file and disk management tools. So Linux disk management includes several important tasks such as adding or removing storage devices, creating and deleting partitions, mounting partitions on appropriate directories, and making file systems in partitions. We cannot create files and directories directly into the partition. Before we use a partition for data storage, we need to create a file system on it. File system is a logical container that is used to store the files and directories. We can create a separate file system type in each partition, or can use same file system type in all partitions. Each partition must be formatted with file systems before it can be used for data storage. Rails supports several large file system types. So guys, we can't just create a partition on a hard drive and start throwing files and directories into it. We have to first create it and format it with a file system before we can start creating those files and file system types. As we talked about earlier, you make those file systems with makefs, and you format the disk with the fdisk command. Okay, and then you would want to mount that file system and put it in that /etc/fs tab to mount it directly once your system boots up. So in summary, we talked about file system types, conventional directory structure, mounting a file system, the etcfs tab file, special files such as device files, inodes, hard file links, soft file links, creating new file systems with makefs, the lost and found directory, repairing file systems with fscheck, the journaling attribute, and file and disk management. Next session, we're going to go over file permissions, directory permissions, octal representation, changing permissions, setting default permissions, access control lists or ACLs, the getFS-ACL and setFS-ACL commands, the sticky bit and the sticky group ID bit, so SUID bit and SGID bit, and the sticky bit. Okay, so it stands for set user ID, set group ID, and then the sticky bit. Okay. Guys, if you're struggling with any of these concepts, you need a little bit extra help, go ahead and click on these links, follow them to our weekly and monthly plans, which will be private tutoring sessions for system administrator management. We also have some private tutoring sessions available for the Linux and Bash scripting. Thank you so much for joining us here on our Session 5 course with codingbootcamps.com. I'm looking forward to seeing you guys in the next session. Hey guys, welcome to Session 7 of Introduction to Linux System Administration. As always, I am your instructor, Kevin Downs. Today, we're going to be covering Linux file security. So last session, we went over file system types, conventional directory structure, mounting a file system, the /etc/fs tab file, special files, hard file links, soft file links, creating new file systems with mkfs or make file system, the lost and found directory, repairing file systems with fscheck, the journaling attribute, and file and disk management tools. Today, we're going to be going over file permissions, directory permissions, octal representation, changing permissions, setting default permissions, access control list, the getFACL and setFACL commands, the SUID bit, the SGID bit, and the sticky bit. Let's go ahead and start with file permissions here and some basic file permissions and permission groups. So each file and directory has 3 user-based permission groups. First one's going to be owner. The owner permissions apply only the owner of the file or directory, and they will not impact the actions of other users. Next, we have the group. The group permissions apply only to the group that has been assigned to the file or directory. They will not affect the actions of other users. Finally, we have other. The other permissions apply to all other users on the system. This is the permission group that you will want to watch the most. So if someone isn't a part of the owner, isn't a part of the group, then they're going to be other. Okay? Let's talk about permission types here. So each file directory has 3 basic permission types. Read. The read permission refers to a user's capability to read the contents of the file. We have write. The write permission refers to a user's capability to write or modify a file or directory. And finally, we have execute. And the execute permission affects a user's capability to execute a file or view the contents of a directory. So let's talk about how these apply to directories. So again, we're going to have read. And on a directory, this is going to give you the ability to read the contents of the directory. For example, do an ls. Next, we have write. And write on a directory is going to give you the ability to write into the directory. So, i.e., create files and directories. So you'll be able to create things inside of that directory. Execute gives you the ability to actually enter the directory. So, in other words, cd into that directory, okay? So these permissions work differently on directories and files, okay? So get familiar with how they interact separately on files and directories. So let's look at octal representation of these permissions, okay? This is a little bit easier way to set permissions, especially if you're trying to do more than one group at a time. So octal notation is a numerical system for modifying the permissions on Linux, Mac, and other Unix-like file systems. Each octal permission can be represented by 3 or 4 numbers, where each of these numbers is an octal, meaning they range from 0 to 7. Each one of the numbers represents permissions that can be set either for a file or a directory. So guys, we're going to see here the octal representation for each one here. So read, or R, is equal to 4, write, or W, is equal to 2, and execute, or X, is equal to 1. Okay. Now, if we add all of these up, we get 7, and we can use any combination of these octals to represent certain permissions. So, for example, I could do 6. And that would represent read and write, okay? And we see that here, 6, so that's for the user group. And we could do 4, which would be read, and that would be for the group permissions. And then we have another 4, which would be, again, read, and that would apply to other permissions. And we can see that here in written form, read, write, write, and write, okay? So when made up of 3 numbers, each one of the octals represent each of the groups that have access to the file. So for example, the octal 724 represents a situation where 7 is the octal for the setting owner permissions, 2 represents the group permissions, and 4 represents other permissions. So here's kind of a breakdown, guys, of that example we just saw up there. So we have owner. The permissions are set to 7, which means they have read, write, execute. Okay, 4 plus 2 plus 1 is 7. Then we have group, which is set to 2. So all they have is write permissions. So we see that up here, write equals 2. And then we have other, which is 4. Okay, so that means other has read permissions, just 4. Alright? So how do we change permissions? So changing permissions, we use the chmod command. So it's quite simple to use this while using octal notation. The structure of the command is simply chmod or chmod, and then octal permissions we wish to set, and then the file directory. So a quick example here. We have chmod 777 myfile.txt. This will give read, group, and other read, write, execute permissions for all of them. Okay, let's actually check this out a little bit on our virtual box here. Let's show a couple examples. So I'm going to do a quick ls. Actually, I'm going to show you where I'm at. Oops. Turn my caps lock off. Alright, so we're at my home directory. I'm doing ls. We see some basic files there. I'm going to create a file. I'm just going to call it testfile.txt. And you'll see now I have that test file. And let me clear my screen real quick. Let's do a long listing to show the permissions on it. So right now, test file has read, write, and read for user, group, and other. Okay, so user here, the first 3, 1, 2, 3. So just read and write. We have group, which are the next 3, 1, 2, 3. Okay, they have read and write. And then the last 3, 1, 2, and 3, which is other. And they have read permissions. Now remember, this first one here is reserved for the file or type. So that's telling me these are all directories. This is nothing here, which means it's a file. Okay, so we're going to do a chmod. We're going to use 777 for test file. Do a long listing again. And now we can see that on that file, we have read, write, execute, and read, write, execute for test file. Okay. Let me clear my screen. We can also take away permissions the same way. So right now it's 777. I could do 444 test file. Do a long listing, and now we see it just has read for the permissions there. Okay. That's how we do it in octal form. That's how we change permissions, and that's how we give and take away permissions, is with that chmod command. Let's head back to our PowerPoint. So how do we set default permissions? So I have a folder which I want to share with read-write permissions for a selected group of users. Let's say the folder is /music, and I want to share it with the group media. What we want to do is not only have users accessing files in music with read-write access, but also to ensure that all files created in music will have ownership, user, media, and permissions read-write, and read. So to achieve this, guys, I'm going to have to use 2 tools. I'm going to have to either use the set group ID or the ACL, which is the access control list, which we're going to go over. But I also recommend doing a man of ACL so you can be familiar with everything that that is capable of. So we're going to go ahead and take a look at the access control list. So files and directories have permissions set for the owner of the file, the group associated with the file, and all other users for the system. However, these permission sets have limitations. For example, different permissions cannot be configured for different users. Thus, access control lists will be implemented. So ACL is included in the default Slackware install. So to activate it, you simply have to remount the drive with the ACL option. Okay. So the get FACL and set FACL commands are how we kind of alter the ACL and access control list. So the set FACL utility sets ACLs for files and directories. Using the -m option, we can add or modify to the ACL of a file directory. So we see that command here, set FACL, -m, and then the rules we want to apply, and then the files we want to go to. Now guys, I'm not really going to go over this because ACLs aren't used that often really in system administration. It's not something that's typically used a whole lot, at least not yet. So there are going to be specific environments where you may use, but really it's not used a whole lot. Instead we use other permissions that we're going to go over here in a little bit. So for each file, get a FACL displays the file name, owner, the group, and access control list. If a directory has a default ACL, get a FACL also displays the default ACL. Non-directories cannot have default ACLs. If the get FACL is used on a file system that does not support ACLs, get FACL displays the access permissions defined by traditional file permission bits. So let me go ahead and pull up VirtualBox here. Let's see if this one will do it for me. Let's go ahead and type get FACL. And then after that, we're going to put in, or we're going to go ahead and hit enter here. Okay, so we need to put the file, yeah. Get FACL. Let's do it on test file. And there you go. You see it displays the owner, the group, and then the permissions on each one. Okay. So that's how get FACL works. Let's head back to our PowerPoint. So the following permissions we're going to talk about here, these are how we actually set up permissions more effectively. So the set user ID or set owner user ID is a special type of file permission given to a file. So normally in Linux and Unix, when running a program, it inherits access permissions from the logged in user. Set user ID is defined as giving temporary permissions to a user to run a program or file.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
The permissions of the file owner rather than the user who runs it. So guys, in simple terms, users will get file owner permissions as well as owner user ID and group ID when executing a file program command. So guys, when we set this user ID bit and you try to run a file with it set on there, you're going to inherit the owner of the file's permissions, okay? So configuring set user ID on your required file script is a single chmod command away. So replace path to file or executable in the above command with the absolute path of the script that you need set user ID bit set on. So we can achieve this by using the numerical method of chmod as well. So we see that below here. The first 4 and 4755 indicate set user bit, or we can do the u plus s executable file to set it. Let's look at that on our VirtualBox here. So let me clear my screen. I'm going to do an LL. So we see there test file.txt. We have read, read, read. So you can do chmod 4 and we'll do 777 test file. So we're setting the user ID bit there 4 on that file. We're going to do another long listing. And then you'll see there it even highlights that test file saying, hey, something special about that. And then you're going to notice here in the permissions we have read, write, and we have an S. And okay, we haven't seen that before. So S is telling you that we have a set user ID bit set, okay? Something else to keep in mind, guys, that also tells us that execute is set, okay? So let me clear my screen again. We're going to do a chmod. We're going to do a 4. Okay. This time, though, we're just going to do a 677 on test file. And we're going to notice something here. Now we notice it's a capital S, okay? So this means the execute is not set, okay? So that's how we know on a file, if we do see that S, whether it's capital or lowercase, whether execute is set or not. Uppercase, not set. Lowercase, execute is set, okay? So that's important to know. I'm actually going to add that in our PowerPoint here. Because that is important to know. So that's in our PowerPoint now. Let's look at the next one here, which is going to be set group ID. So the set group ID bit is very similar to the set user ID bit, except the set group ID bit is set on an executable file, and the effective group is set to the group of the file. So the process runs with the permissions of the members of the file's group rather than the permission of the person who launched it. So it's pretty identical, except now we're inheriting the group permissions rather than the user permissions. So set group ID permissions is similar to set user ID permissions. The only difference is when the set scripter command with set group ID is running, it runs as if it were a member of the same group in which the file is a member. So set group ID can be set doing chmod g+s in the file or directory, or in the octal form chmod, and now we use 2, and then the permissions on the file directory. And we can see that below here. See an S here. So let's go ahead and do that on our virtual box here. So real quick, I'm actually going to take away the set user ID bit. How I'll do that is user minus, remember minus takes away permissions, S, and then test file. Do a long listing, and now we see that that S is gone. Let me clear my screen. So now we're going to do chmod, do 2777 test file. Do a long listing, and now we see in the group, so user read write execute group read write S. So now we have that group ID set. And again, if I were to change this to where executable is not given to group, oops, we'll notice that S change. And now you can see it's a capital S. Okay. I'm going to add that as well into our PowerPoint. That is important to know. Alright, let's go ahead and head back to our PowerPoint here. Let's talk about the last one here, which is going to be the sticky bit. Okay. The sticky bit is primarily used on shared directories. It is useful for shared directories such as /var temp and /temp because users can create files, read and execute files owned by other users, but are not allowed to remove files owned by other users. Okay, so for example, if user Bob creates a file named /temp/Bob, other users Tom cannot delete this file even when the /temp directory has permissions of 777, meaning everyone has read, write, and execute. Okay, if the sticky bit is not set, then Tom can delete /temp/Bob as the /temp/Bob file inherits the parent directory's permissions. Okay. So if that's not set, then everything in /temp is read, write, and execute. Anybody can delete anything, okay? Now root user and owner of the files can remove their own files. Obviously root user can do that because it's a super user, and basically root user can do anything it would like on the system. And that's why we don't want to give people root permissions if we don't have to, okay? So we see here below how to set the sticky bit. We can do chmod +T, or we can do a 1 in the octal form now, okay? So let's check that out on our virtual box. Do an LL, let's see our permissions. Let's go ahead and remove the group permission, so G-S. the set group ID one, test file. We're doing LL. We see it's removed now. Okay, it's no longer there. So let's clear the screen. We do chmod 1777. We do a long listing. And this time we see a T. T for sticky bit. I can't tell you why a T is here instead of an S. I'm not sure who programmed or made this permission up, why they decided a T. But that's what it is. It's a T, sticky bit. Okay? And guys, again, if we do 776 on that file, can you guess what's going to happen? That's right, it's going to be capitalized because it does not have executable permissions. Again, I'm going to put that in our PowerPoint. So those are the more effective permissions as opposed to access control lists, okay? So let's go ahead and summarize what we learned today. Today we went over file permissions, directory permissions, octal representation, changing permissions, setting default permissions. We took a very brief look at access control lists and the get FACL and set FACL commands. And we went into set user ID bit, set group ID bit, and the sticky bit. Next session, we're going to go over characteristics of processes, parent-child relationship, examining running processes, background processes, controlling processes, signaling processes, killing processes, automating processes, cron and cron tab, and batch commands, and system processes. So we're going to really take a deep dive into processes, guys. If you need a little bit of extra help or you're struggling a little bit, go ahead and click on these links, guys. Follow them to look at our weekly and monthly plans for private tutoring sessions for system administrator management, as well as Linux and Bash scripting. Thank you so much for joining me today, guys. I hope to see you in session 8 next, and I hope you learned a lot today. Hey guys, welcome back to session 8 of Introduction to Linux System Administration. This is going to be our last session for this course. As always, I am your instructor, Kevin Downs. Today, we're going to be finishing up with controlling processes. So last session, we went over file permissions, directory permissions, octal representation, changing permissions, setting default permissions, access control lists, the get FACL and set FACL commands, and the set user ID bit, as well as the group ID bit and the sticky bit. Today, we're going to be going over characteristics of processes, parent-child relationship, examining running processes, background processes, controlling processes, signaling processes, killing processes, automating processes, cron and cron tab, and batch commands, and system processes. So guys, basically we're going to be looking and discovering all about processes and how to control them, okay? So let's go ahead and look at characteristics of processes. So processes carry out tasks within the operating system, and a program is a set of machine code instructions and data stored in an executable image on disk, and is as such a passive entity. A process can be thought of as a computer program in action. Okay? It is a dynamic entity. Constantly changing, the machine code instructions are executed by the processor. In addition to the program's instructions and data, the processes also include the program counter and all the CPU's registers, as well as the process stacks containing temporary data, such as routine parameters, return addresses, and saved variables. So the current executing program or process includes all the current activity in the microprocessor. Linux is a multi-processing operating system, and processes are separate tasks, each with their own rights and responsibilities. As such, If one process crashes, it will not cause another process in the system to crash. Each individual process runs in its own virtual address space and is not capable of interacting with another process except through secure, kernel-managed mechanisms. So let's look at the parent-child. Let's look at the parent-child relationship. Every process has a parent process, meaning that when a process is created, something created that process, and it may or may not have child processes. Let's take this one by one. Consider the output of PS command now. So when a process creates another process, the former is called the parent, while the latter is called the child process. Technically, a child process is created by calling fork function from within the code. Usually, when you run a command from the shell, the fork is followed by exact series of functions. Okay. So guys, what this fork thing means is that we create a process, and then more processes can be created off of that and create like a fork. Okay. And then you can see how that would keep forking off of one another, etc., etc. And each time a process is created, that's known as the child process, and the process that created it is the parent process. This is important to know because if you have a process that's running wild and you need to stop it, stopping the process might not be the actual solution. You may need to find the parent process of that process and stop that one to truly stop what's going on. So to examine running processes, the Linux terminal has a number of useful commands that can display running processes, kill them, and change their priority level. Here we list the classic traditional commands as well as some more useful modern ones that we'll discuss. We have top, htop, ps, pstree, kill, pgrup, and pkill, which is process kill. We've looked at a few of these such as top, ps, and kill, but we can go ahead and pull these up again just to show you them. Let me log in here. Oops. Come on. There we go. Clear my screen here. Let's do a top. So remember, top is a live view of what's going on in our system. All the different processes, the CPU usage, and memory usage. To get out of top, we hit Q or quit. Remember, top will stay there though, even when we hit quit, so we'll clear our screen to get some more space. We can do PS to list the running processes. In this case, all we have is bash, which is our shell running, and then PS, which is the PS command we just ran. Okay, and then we could type in kill to run to kill a certain process, but we'll look at that a little bit later. Let's go ahead and head back to our PowerPoint here. So next we're going to look at background processes and how those. So a background process is a program that is running without user input. A number of background processes can be running on a multitasking operating system such as Linux while the user is interacting with the foreground processes.
Thanks for watching. Please like and share this video.
So some background processes, such as daemons, for example, never require user input. Those are going to always run without you having to need them to run. Those are the ones that are controlling different processes, startup programs, as well as other things that our system needs to run. So to control processes, we have the background command, which is a process control command that resumes suspended processes while keeping them running in the background. So we can type and do our normal commands and administration without having to worry about those commands running. So users can run and drop in the background by adding a ampersand symbol or the and symbol at the end of the command. So background puts suspended processes into the background, foreground brings processes into foreground, and jobs list processes. Let's take a look at that real quick. So let's say I want to do the sleep 60 command, which just puts my terminal to sleep for 6 seconds. Right now I can't do anything with my terminal. No matter what I type in, it's not going to free up. So I'll do Control C to get out of that. This time I'm going to do sleep 60. I'm going to put it in the background. Now I can do things and have access to it while that's running in the background. You'll even see it told me the job started running here. It gave me a job number. So if I run jobs, you'll see that the sleep 60 command's running there. Okay, I can even kill that job by running its job ID. Oops. Let's do a PS command. So now I can do kill, And you'll see the process ID here, 3564. 3564. And that job was killed. Okay. Clear my screen. Let's head back to our PowerPoint. Oops, there we go. So the foreground command moves a background job in the current shell environment into the foreground. So we can use the job ID parameter to indicate a specific job to be run in the foreground. If this parameter is not supplied, the foreground command uses the job most recently suspended, placed in the background, or run as a background job. And as we just saw, the jobs command is used to list the jobs that you're running in the background and the foreground. So the signals and processes control almost every task of the system. We get the following response at ps-ef. Okay. So when we type that in, we can see all the different processes running. So let's go ahead and take a look at some of those commands we just talked about. So we talked about how we can put sleep 60 in the background with that ampersand symbol. Oops. There we go. So now it's in the background. I can do FG. And I'll actually bring it to the foreground again. This isn't going to let me use my terminal. So I can do Control-C, get out of that. I can do ps-ef. Now we see a lot more processes when we run it with the EF command, right? So typically when you do the EF command, or the EF flags, you're also going to want to run it with grep. I'm going to say sleep. And we'll see there, we see the sleep command running. We're going to go ahead and kill that command using the process ID of it, which is 3630. And we see that right here. Okay, 3630. Okay, so I need to run that as root. You can see there that process was started by root. And as such, I'm not going to be able to kill it because I'm not root. Okay, let me go ahead and clear my screen here. And that process will finish in 60 seconds, so I'm not too worried about it. I'll let it finish on its own. That's how foreground and jobs. Remember, I can run jobs and it'll show different jobs running. Right now, there are no jobs running. So let's head back to our PowerPoint. Here's a small diagram of the process state and how it works. So first we have a process, it's created, the system accepts it, it's in the ready state, and then it can start running, and when it finishes, it'll get terminated and exit the processor. Or we can create the job, it gets accepted, it starts running, okay, and then we interrupt it, and it goes back to the ready state, meaning we can run it again. And then we go through that same process, running, it finishes, and it terminates, okay. Or we can have a process, it gets accepted, it's ready, it runs. We run a suspend signal, where it has to wait, and it's in the waiting state. And then as soon as the suspend signal is taken up, it can go back to the ready state and run, and then finish out, okay? Guys, this diagram actually kind of overcomplicates things. You just need to think of it simply. You know, jobs will run. When they're finished running, they're going to exit out, okay? If you're running a job, you can interrupt it or suspend it and then resume it when you want it to finish, or you can even just cancel it, okay? So this is just trying to show a diagram of how jobs run on the system. So let's talk about killing processes. There are also different signals that can be sent to kill commands. What signal you send will be determined by what results you want from the kill command. For instance, you can send the hup hang-up signal to the kill command, which will effectively restart the process. This is always a wise choice when you need the process to immediately restart. This is the case for daemons. You can get a list of the signals that can be sent to the kill command by issuing kill-l, and you'll find quite a large number of signals. And guys, I'll go ahead and show you that right now. I'm not going to go over all of them. I just want you to see it though, in case you ever forget them. The main ones we're going to look at are 9 right here, which is sig kill. Okay, and 15, which is sig terminate. Okay, which are the gracious and not so gracious way to kill programs. Let's head back to our terminal. Or I'm sorry, our PowerPoint. So we can send the kill signal to specific processes based on their process ID, which we can find out via the jobs command or the PS command. We can find out from our PS command that the IDs we want to kill, and these are just examples that we see here below, are 3827, 3919, 10764, and 11679. So to send them kill signals, we'd issue the commands below. Kill-9 and then process IDs on these. These will kill the process immediately, okay? In case you don't want that process running anymore, this is how you would kill them. Next, guys, we're going to look at how to automate processes. So guys, automating processes can be super handy as a sysadmin, because if a sysadmin spends most of his time solving issues and doing repetitive tasks, you can suspect he or she is not doing things quite right. So in other words, an effective sysadmin or engineer should develop a plan to perform a repetitive task with as less action on his or her part as possible. Okay, this can be done via Ansible, guys, bash scripting, which is a very simple way to do things, or we can even use cron to automate some things. Okay, we're going to look at an example of a bash script here. I'm not going to go into it too much, but let me see if I can zoom in on this a little bit. Yeah, there we go. So this is an example of a bash script. Here we see some quote or hashtag marks or pound symbols, and these are comments in the script, meaning the system won't read them. Okay. Let me get the screen centered a little bit better here. There we go. And it tells you what the script's going to do. It says this script will return the following set of system information, hostname information. And we see here echoes -e, it's going to give the hostname information. And it'll tell us the file system disk space usage, echo-e file disk space usage, and the free and used memory in the system. And it goes on to explain other things, who's currently logged in, and top 5 memory consumed processes. Okay, so we can write all that up. It'll take a bit of time up front to write all that, but from then on, we can run that script whenever we need it to do those things for us. And then that way, we don't have to type it in every time. We can just say, execute the script, and it'll give us all that info from then on. And we don't have to do it one by one. Here's another example of a script here. Let me zoom in on it for you. I'm trying to, there we go, get it centered for you guys. Okay. So we see we run that script, which we called systeminfo.sh, and sh, whenever you see it in an sh, is a shell script. So we had those things in the script, and then when we run that command, it spits out all this information for us. It tells us host name, icon name, chassis, machine ID, boot ID, etc., etc. It's going to tell us file system and disk space usage here, so file system, what's being used, free and used memory. Oops. And then the system uptime and load, okay? So this script in particular is just a quick and easy way to get some system stats. Alright. Again, we're not going to go too much into that, just because later on in our next courses we will actually explain bash scripting right now, and I don't want to confuse you guys too much on how that works. So let's look at another way to automate some things, which is through cron and cron tab. So the cron tab command, found in Unix and Unix-like operating systems, is used to schedule commands to be executed periodically. To see what cron tabs are currently running on your system, you can open a terminal and run cron tab-l. And they're going to be written in the following format. You're going to see all these asterisks or stars, and then the full path to your script. Let's go ahead and go to my system. I shouldn't have any cron tab or cron jobs on here, and that's what they're called, guys. When you have a task in there, it's called a cron job. So let me do a cron tab-l. I shouldn't have any. Yep, and it says no cron tab for kdowns. I can do a cron tab-e, which is to edit the cron tab. Oops. Cron tab-e, yeah. You'll see I could enter in different cron jobs here. And I'd have to do it in the format that we're about to discuss here. So we see this format here. Here's how we have to do it. All the stars. And there's 1, 2, 3, 4, 5 of them. Okay. And we see which each one means here. So as you can see, there are 5 stars. The stars represent different date parts in the following order. First one is minute. Second one is hour. Third is day of the month. Fourth is the month. And the last is day of the week. And 0 equaling Sunday. So minute 0 to 59, hour 0 to 23. Day of the month 1 to 31. Remember, not all months have 31 days, so be aware of that. The month 1 to 12. And the day of week 0 to 6, 0 being Sunday. Okay. So if I wanted to set something at 8:30 a.m. on Tuesday in February, the first Tuesday of the month, I would do 30. Since we're doing 8:30, hour 8. Remember, it's in military format, so 8. So now it's 8:30. Day of the month, I would say the first one. Okay, so when I put 1, it's just going to default to the first Tuesday of the month. Okay. And I say the month. I said February, so we're going to put 2. And then the day of the week, which would be 2. 0 is Sunday, 1 is Monday, 2 is Tuesday. Okay. So actually, let me show you that real quick. So if I wanted to do that, I would do cron tab -e. It would be 30. Okay, 30, 8. And then we said day of the month. We're going to put the first one, since I want it to be the first Tuesday. The month, February, which would be 2. And then the day of the week, which is going to be Tuesday, which will also be 2. And then I don't have a script written up, but I could do /bin/example.sh. And it would run that example script on the time I just specified. I'm not going to save this, guys. Oh, I don't know what just happened, but I'm not going to save this. I'm going to quit out of that. You can see cron tab -L. I still have nothing in there, okay? But that's how you would set it up. Let's head back to our PowerPoint. So that's how cron and cron tab works, guys. Alright, let's go ahead and talk about the at and batch commands. So the at command schedules a command to be run once at a particular time that you normally have permissions to run. So guys, the cron jobs and the cron tab is going to run every single time that date that you put in occurs.
Thanks for watching. Feel free to add your questions as comments down below.
At is going to run one single time. The at command can be anything from a simple reminder message to a complex script. You start by running the at command at the command line, passing it to the scheduled time as the option. It then places you at a special prompt where you can type in the command or series of commands to be run at the scheduled time. When you're done, you hit Control D on a new line and your command will be replaced in the queue. So a typical command sequence is going to look like this below. So we say at 9:30 p.m. on Tuesday, and then we run a certain command. Batch executes commands when your system load level permits. In other words, when the load average drops below 1.5 or the value specified in the invocation of ATD, okay, which is the at daemon, guys. Anytime we see a D behind something, that usually means it's the daemon of that processor command. Okay, so let's look at that real quick. So I'm going to say at, I'm just going to type in at, so you can give me a special prompt. Oop, sorry, I need to put the time. So I'm going to say at 9:30 p.m. on, let's say like Friday. And it holds that up. I'm going to say run an ls command, that's it. And I also want you to run a date command. And while we're at it, why don't we run a who am I command. And then that's all I wanted to do, so I click Control D. It's going to say, okay, at Friday, August 21st, at 9:30 p.m. on 2020, it's going to run these two commands. Okay. The at command, guys, is much more loose with the times you can put in. I could even say at tea time tomorrow. Say ls date who am I. This is kind of funny, guys. Watch what it outputs for us. So it says, okay, at Friday, August 21st, which is tomorrow, at 4 o'clock, I'm going to run those commands, okay? So it's much more loose with how you can type in the times, okay? So let's head back to our PowerPoint. Let's talk about system processes known as daemons. So a daemon is a type of program on Unix-like operating systems that runs unobtrusively in the background rather than under the direct control of a user. So waiting to be activated by the occurrence of a specific event or condition. Monitoring a system is a good reason to use a daemon. Cron can run processes every minute, but if you need a tighter granularity than that, cron can't help. A daemon can, though. So with a daemon, you can set up whatever timing you want in your main loop. So in summary, guys, file permissions, directory permissions, octable representation. Oops, sorry guys, I think we got these mixed up here. There we go. So today, guys, we went over characteristics of processes, parent-child relationship, examining running processes, background processes, controlling processes, signaling processes, killing processes, automating processes, cron and cron tab, at and batch commands, and system processes. As always, guys, please click on these links if you need extra help so you can view the weekly and monthly plans available for private tutoring sessions for system administrator management, as well as Linux and Bash scripting. I strongly encourage you to continue your education. We have more sysadmin training, such as Intro to Cybersecurity, Introduction to Cloud Technology, How to Manage Windows Servers, Introduction to Database Design, Learn SQL Programming with examples, Introduction to NoSQL Database Design, Learn Graphic Database Design with examples, What is Linux operating system and how it works, What are directory tree and file system hierarchies in Linux. These are all resources you can look at, guys, in addition to what we talked about. Introduction to Linux file systems for system admins. Overview of Linux virtual memory and disk buffer caches. More resources are best practices for monitoring Linux systems, best practices performing Linux boots and shutdowns, and best practices for making and managing backup operations. Some classes to take immediately after this, guys, are how to manage Red Hat or CentOS Linux servers in intermediate level. Learn PHP programming, web developer with PHP and MySQL, advanced Linux Bash scripting, which is another class I'll be teaching, intro to HTML and CSS, introduction to Python programming. And guys, I'll also be teaching this how to manage Red Hat or CentOS Linux servers. Okay. And thank you so much, guys, for joining us on this course here. This has been a course provided by codingbootcamps.com. I am your instructor, Kevin Downs. Be sure to follow us on social media platforms, and I really hope to see you in these other courses that we have available, guys. Hey guys, congratulations, you did it. You completed the course, Introduction to Linux System Administration. Very proud of you, very happy for being able to push through and learn some of these tougher concepts of what a sysadmin does. So we're going to talk about some topics that we actually went over in this course. So we went over System Administration Overview, Installation and Configuration, Booting and Shutting Down Linux, Managing Software Devices, Managing Users and Groups, the Linux file system, Linux file security, controlling processes, and we also did 3 homework assignments that went over managing users, groups, permissions, access control, and more. Okay. So again, congratulations, you've successfully finished this class. Be sure to continue on, guys. Don't be satisfied with what you learned just in this course. Be sure to do other courses, continue your learning, do more hands-on projects, and keep learning as much as you possibly can. You want to keep these skills fine-tuned and up-to-date, so continue to use everything that you've learned so far in this class, okay? So some follow-up classes you can take, which we have available, is Learn PHP Programming, Intro to Linux Bash Scripting, and that will be another course that I teach, okay? How to manage Red Hat or CentOS Linux servers, intermediate level. So that would be a good one to take immediately after this class. That'll be the intermediate level, and that is a course that I will be teaching. And Intro to HTML and CSS, okay? So guys, again, thank you so much for taking this course. This has been a course provided by codingbootcamps.com. Be sure to follow us on social media such as Twitter, Facebook, YouTube, or LinkedIn, okay? And I hope to see you guys again on the next course, whatever that may be, whether it's with me or a different instructor. I hope to see you guys continue your learning. Thanks. Bye.